Thank you all for joining us today. In a truly hybrid format, we have a mixture both of audience and presenters today, in the physical space as well as on the virtual space. So thank you all for being here in one form or another today. My name is Megan Rogales, and I work for the Partnership for the Delaware Estuary as the Schuylkill Action Network Manager. It is a privilege to be here today hosting SAN's 2022 Water Utility Forum in collaboration with Aqua. This biennial forum is one of several key aspects of the SAN's Pathogens and Point Source Workgroup, and today's meeting is in place of the quarterly workgroup meeting that happens in the first quarter of the year. Thank you again for joining us. If you're unfamiliar with this workgroup, it offers a great opportunity for utilities to network and collaborate, learn about contaminants of emerging concern and other compliance-related issues. And if you're interested in learning more, if you don't know us already, please check us out at schuylkillwaters.org. I wanted to take a moment before we get started into our agenda today to give a hearty thanks to the team here at Aqua for hosting us, and in particular, Krista Shire, Aqua's Corporate Giving and Community Affairs Representative, who's done an amazing job at doing so much behind the scenes effort to make this event happen today. So I just wanted to specifically call you out and acknowledge you, Krista. Thank you so much for all your support making this event happen. In addition, I wanted to acknowledge Katie Evers, sitting over here to my right. Apologies for those of you online who can't see her right now. She is the engagement specialist from Partnership for the Delaware Estuary and has been instrumental in her support of all things SAN since starting this past fall, and is a key person working behind the scenes today to make this event happen. I also would like to recognize Kate Huddlemeyer, who those of you in the room saw earlier today, PDE's Senior Engagement Manager, who's here with us in person, and Haley Burns, PDE's Program Specialist, who is in the virtual room helping us monitor the chat and the Q&A today. So thank you all. I'd also like to thank the members of SAN's Pathogens and Point Source Workgroup, and especially the subcommittee who helped organize this event, for connecting us to a lot of great presenters who are here to share with us today. And finally, I want to make sure to thank our suite of presenters for coming and sharing your expertise. Today's event really wouldn't be possible without the support of all these people behind it. So thank you all. So to move on, just to get us oriented for the day, a brief review of the agenda. Those of you here in the room have it in your packets. And there's also a virtual agenda online that those of you joining us virtually should have available to you. Thank you, Haley, for including that in the chat. So a few notes as well for our virtual attendees. We will be recording today's event. Please be sure to post your questions in the Q&A tab on Zoom. And since we are here today at Aqua and we have a founding member with us, with Dr. Crockett, I was hoping he might be able to say a few words to us and kind of introduce and welcome us to Aqua a little bit more today, if you don't mind me putting you on the spot. Yeah.
Actually, I was just, I'm dealing with 2 news requests today about PFAS. So I just got a request from WH where I was standing there about something. So I'll be quick. It's very timely. We're talking about PFAS today. First, I just want to mention, welcome you to Aqua / Essential Utilities. We have in this building is an $8.5 million building that was built during COVID. Construction started a week before COVID shut it down, and then we finished it and moved in about a year ago. Meanwhile, the entire lab team of 20 people that you'll see today worked every day through COVID in person on site, except for one day, Christmas Day, they get off. They're allowed to get 1 day off a year. They work very hard, and you'll find there's a dedicated team of people here. I hope you look forward to the tour. This building receives 30,000 plus bottles for samples a year, which turns into 90,000 analyses, which then results in about 250,000 analytical results that we report every year. We do testing mainly for Pennsylvania and New Jersey, but we also run samples for all 8 states that Aqua is located in, including the PFAS testing that we did for all 1,500 of our systems throughout the 8 states. We do have 1,000 500 systems, and we have several thousand groundwater wells that we operate and maintain, in addition to the big surface water supplies you're going to see and hear about today. So all these different issues that you're working on, source track downs, whether it's PFAS or pathogens, which are very near and dear to me, and some of the work that we've seen many of you work on through the years, we have seen the progress in the watershed that you've made addressing these sources and the constant work that you have to make to keep working on it. And we really appreciate everything you've been doing as members of SAN. So thank you. Please, if you can, take the tour, great. But I really appreciate you for coming today. And for those of you presenting remotely, we look forward to seeing you in person soon. And we look forward to collaborating more in the future to make the watershed better. Thanks.
Thank you so much. So now we're going to move on to our first presentation of the day. Thank you for those of us that, bearing with us as we kind of got settled in here. So it is my pleasure to introduce our first presenter, Marissa Rossi. Ms. Rossi is currently an MS candidate in environmental science at Villanova University. She's completing her thesis research under the guidance of Dr. Stephen Goldsmith, focusing on the impacts of impervious surface cover and roadway de-icing agent application on the water quality of rivers and streams in exurban and suburban watersheds. You can read her full bio virtually and in the packet here, but just a quick introduction of Marissa, and thank you so much for joining us today, Marissa, if you can come up to the podium.
Okay, so hi everybody, thank you for being here today. My name is Marissa Rossi, and I'm a master's student at Villanova University. And I will be graduating this coming June. So the research that I will be sharing today was done under the direction of my advisor, Dr. Stephen Goldsmith, and it was also done in collaboration with Dr. Peleg Kramer, who's a professor at Villanova, Dr. Charles Cravata, a professional with the USGS, and then Krista Shire from Aqua, Pennsylvania. So thank you to all of them for their help with this project. So the title of my presentation is Watershed Insights, a review of 20 years of source water monitoring data. And today I will be specifically sharing on the impacts of impervious surface cover and roadway de-icing agent application on the water quality of 6 rivers and streams in southeastern Pennsylvania. And all of these watersheds are located in the same geographic region and have demonstrated patterns of exurban and suburban growth. Okay, so many of us are familiar with the image on the right. We see these trucks throughout the Northeast, Mid-Atlantic, and North Central regions of the United States. During the winter months, these trucks will come out and spread road salt behind them, which keeps the roads free and clear of ice and safe for people to travel on. However, it's important to look at how annual road salt application is changing in the United States. So a study by Kelly et al. In 2012 looked at the annual road salt application data from about the 1940s until 2009. In the 1940s, we see that they applied about 5,000 metric tons of road salt. And by 2009, we were applying over 20 million metric tons. That's approximately a 20-fold increase since the 1940s in the United States alone. And for anybody that's wondering, 20 million metric tons is about 27 billion of these Morton salt canisters. Due to all of this road salt, we've seen increasing chloride concentrations in stream water. A study by Kaushal et al. In 2005 in the Hubbard Brook Valley in the White Mountains of New Hampshire compared chloride concentrations in a forested reference stream and a stream near the highway. They found that in the forested reference stream, the chloride concentration remained near zero and was not increasing over time. And in the stream near the highway, the chloride concentration was both elevated and increasing over time. Similarly, a study by Kelly et al. In 2008 in the Wappinger Creek in Millbrook, New York, compared chloride concentrations in both the winter and summer months. They found that chloride concentrations were increasing over time in the winter and summer months, and they were relatively similar. This indicates that chloride has infiltrated into the soil and entered the groundwater, where it is released into the stream over time as base flow. This leads to the higher summer concentrations, even when there are no significant road salt inputs. There have also been documented links between chloride concentrations and impervious surface cover. A study by Bird et al. In 2018 compared chloride concentrations in the Piedmont and Baltimore, Maryland in watersheds with varying degrees of impervious surface cover. They found that in the watershed with 0% impervious surface cover, so in the forested watershed, there was little to no chloride and the concentration was not increasing over time. And you can see that in the figure by the dark green line. Surprisingly, with just an increase of 1% impervious surface cover, the chloride concentration was elevated and started to increase over time. And you can see that by the light green line. And then in the two watersheds with the greatest percentages of impervious surface cover at 17 and 21%, the chloride concentration was the most elevated and increasing at the greatest rate over time, which you can see by the pink and red lines in the figure. So though there are studies that look at chloride concentrations over time and the relationships with impervious surface cover, there are still some gaps in the knowledge base. There's currently a lack of long-term stream water chemistry data that has associated flow data. And there's also a lack of studies that evaluate multiple watersheds over time in the same geographic region. And more specifically, there's a lack of studies that look at exurban and suburban watersheds, which are often where we see the most developmental pressure. So my question is, what is the relationship between impervious surface cover change, long-term chloride concentrations, and road salt application rates for 6 exurban and suburban watersheds in southeastern Pennsylvania? And as you can see in the map, all of these watersheds are located in the Philadelphia metro region and experience developmental pressure due to their location. And I just wanted to point out 3 watersheds before we move on. Neshaminy, which is located up here, and that is it's located northwest of Philly, and then we have, or northeast of Philly, and then we have Crum located to the west of Philly, which is down here, and then Chester, which is to the west of Crum. So these 3 watersheds will come up later on in the presentation. I'm going to take you through some of the land uses that you can see in this figure, but first I just wanted to note that most of the streams are flowing from the north-northwest direction to the south-southeast direction. So one of the type of land uses that we can see in these watersheds is developed land. Developed land also often looks like the figure on the left. It's composed of sidewalks, roads, buildings, and parking lots. In the figure, developed land is indicated by the varying shades of pink and red. These watersheds are mostly exurban and suburban in nature, so we see more of developed open space and developed low intensity land, which is indicated by the lighter shades of pink, rather than developed medium intensity and high intensity, which is indicated by the darker shades of red. We also see forested land in these watersheds. Forested land often looks like the image on the left, and in the map, it's indicated by the varying shades of green. And finally, we see cultivated crops and pasture. Cultivated crops often looks like the upper image, while pasture often looks like the lower image. In the map, hay and pasture is indicated by the yellow, the various shades of yellow, and then cultivated crops is indicated by the shades of brown. So because we see these 3 different types of land uses within these watersheds, we see developed land, forested land, and agricultural land, it really makes them exurban and suburban in nature rather than purely urban watersheds. So to address some of the knowledge gaps that I mentioned previously, such as a lack of long-term stream water chemistry data that has associated flow data, and a lack of studies that evaluate multiple watersheds in the same geographic region, I had 3 study goals. We wanted to determine the change in impervious surface cover in the study watersheds. We also wanted to determine the change in flow normalized chloride concentrations in the study watersheds. And finally, we wanted to determine the relationships between impervious surface cover, flow normalized chloride concentrations, and road salt application rates. So now I'm going to take you through some of my methods and the various data sources I used to accomplish these study goals. So first, I wanted to determine impervious surface cover, and to do so, we used the 30-meter resolution imperviousness data set for the years 2001 to 2019 from the National Land Cover Database. And in the map on the right, you can see the imperviousness data for the year 2019. We also wanted to determine road salt application. So we had access to the Pennsylvania Department of Transportation state road data set, and we also had access to the countywide salt application data set from the Pennsylvania Department of Transportation. Using the state road data set, we were able to determine the proportion of the area of roads within the watershed to the area of roads within the county. Using this proportion, we were able to determine how much of that countywide road salt was applied within each of the watersheds. We also wanted to determine the amount of road salt that was applied to non-state roads and other impervious surfaces. To do so, we determined the area of non-state roads and other impervious surfaces using a high-resolution land cover data set for the Delaware River Basin. We also needed water chemistry data, which we had access to a long-term water utility source data set from Aqua for the 6 watersheds that I mentioned previously. This data set has monthly measurements for chloride from 1997 to 2019 in 3 of the watersheds, so about a 23-year study period, and from 1999 to 2019 in the other 3 watersheds, so about a 21-year study period. We also needed stream discharge data, which we downloaded from the U.S. Geological Survey's National Water Information System, and we were specifically interested in the daily mean discharge data. So using the water chemistry data and the stream discharge data, we were able to determine flow normalized chloride concentrations. We did so using the WRTDS model, which stands for the weighted regressions on time, discharge, and season. This model removes the impact of yearly discharge variation. And it's accessed through the EGRIT program, which stands for Exploration and Graphics for River Trends. And all statistical analyses were conducted in R. So now I'm going to share some of the results of my study. I'm going to show you a variety of figures. They all have year on the x-axis and the variable on the y-axis. This first figure shows impervious surface cover change. So we see that impervious surface cover is increasing in each of the 6 watersheds from 2001 until 2019. It's important to note that these watersheds have relatively low amounts of total impervious surface cover. In 2019, it ranges from only about 6.8% to 14.2%. And I want to draw your attention to the 3 watersheds that I mentioned previously, Neshaminy, Chester, and Crum. These 3 watersheds had the greatest percent change in impervious surface cover over the study period. Neshaminy in red had a percent change of about 1.9, Chester in blue had a percent change of about 2.3, and Crum in yellow had a percent change of about 1.7. Though this might not seem like a lot of change in impervious surface cover, previously I mentioned that studies have shown that an increase of just 1% impervious surface cover can lead to elevated and increasing chloride concentrations. So this 1% change in impervious surface cover can be pretty significant. So now we see the results for the flow normalized chloride concentrations. And we see that chloride is increasing in all 6 of the study streams. And once again, I want to draw your attention to those 3 watersheds, Chester, Neshaminy, and Crum. These 3 watersheds had the greatest change in flow normalized chloride concentrations over the study period. Chester had a change of about 60 milligrams per liter. Neshaminy in red had a change of about 49 milligrams per liter, and Crum in yellow had a change of about 54 milligrams per liter. And so even though these watersheds didn't have that great of a change in impervious surface cover over the study period, we are still seeing dramatic changes in the chloride concentrations. And in some cases, we're seeing an increase of chloride of about 2 to 3 milligrams per liter per year, which is a pretty significant change in chloride concentrations. So we wanted to determine, where does all this salt and where does all this chloride come from? So we took a mass balance approach in which we calculated the mass of various inputs into the watershed. And so we calculated the mass of chloride that would come from things such as precipitation, excretion, household waste, the treatment of wastewater, agricultural potassium chloride, state and non-state roads, brine, calcium chloride, and other impervious surfaces. And you can see in the figure, it has the various mass of all of these inputs from the years 2011 to 2018 in Chester watershed. And we also wanted to determine the amount of chloride that was retained within the watershed. So you can see that in the figure by the dark red line. So when the line is positive, it means that chloride was retained within the watershed. And when the line is negative, it means that there was an overall release of chloride from the watershed. So based on the chloride inputs, we're seeing that road salt accounts for the majority of these chloride inputs. And this road salt is applied to both state and non-state roads, and it's also applied to other impervious surfaces. And based on the red line, though I'm just showing Chester watershed here, on average across all 6 of our study watersheds, approximately 30% of annual inputs are retained in shallow groundwater. This is largely responsible for the increasing chloride trends that I showed on the previous slide, as chloride is retained in the groundwater and released into the stream over time. So now we know where all this salt is coming from and what's happening to the chloride concentrations. We also wanted to look at the relationships between chloride concentrations and impervious surface cover. So we compared the percent change in developed low intensity land to the change in the chloride concentration. And we found that watersheds with the greatest changes in low intensity development also had the greatest changes in flow normalized chloride concentrations, which you can see by the positive trend line on this figure. This shows that watersheds with limited impervious surface cover can impact water quality. All of our watersheds only range from about 6 to 14% impervious surface cover. And it also shows the impacts of exurban and suburban growth. We also looked at the relationship between chloride concentrations and developed medium and high intensity, and this relationship started to fall apart. So it was really just with developed low intensity, so it shows the impacts that exurban and suburban growth can have on chloride concentrations. So due to all this road salt, there are likely impacts to freshwater organisms that I'm happy to talk about later on. But due to today's audience, I wanted to focus on the implications to water quality and also to drinking water infrastructure. So first, I'm showing a figure of sodium. So we saw that chloride concentrations were increasing in the source water, but we also see that sodium concentrations are increasing in the source water. This is important because the US EPA set a recommended threshold for those following a low sodium diet of 20 milligrams per liter. And we see that in 2019, all streams exceeded this threshold value. In 3 of the streams, they were more than double this threshold value of 20 milligrams per liter. And these concentrations are likely going to continue to increase during the treatment process. We also wanted to look at the impacts to drinking water infrastructure. So we specifically looked at the chloride to sulfate mass ratio, which is an indication of corrosion potential. So this chloride to sulfate mass ratio is just the ratio of chloride to sulfate. As you saw previously, the chloride concentration is increasing in each of the 6 watersheds. Though not shown in this presentation, we also know that the sulfate concentration is remaining steady or decreasing due to less acid rain. So with the chloride concentration increasing and the sulfate concentration decreasing in each of the 6 watersheds, we see that the chloride to sulfate mass ratio is increasing across all 6 watersheds. This means that there's an increased corrosivity potential of pipes, and the threshold found to cause corrosion in pipes is only 0.5. In Crum watershed, we're seeing up to a chloride to sulfate mass ratio of almost 7, and it's been increasing over time. Even in the beginning of the study period at 1997 and 1999, we still were not below this 0.5 threshold value. This can lead to increased corrosion of copper and lead from pipes and can ultimately lead to greater cost for treating drinking water. So one of the solutions that has been proposed is to reduce impervious surface cover. Though in these developing watersheds, impervious surface cover has been increasing. So it's important to look at other solutions. Another solution that has been proposed to road salt is to apply more brine rather than road salt. So brine is basically a saltwater mixture that transportation departments can apply prior to a winter storm event, and it prevents snow from sticking to the road surface and ultimately reduces the total amount of salt that that the transportation department will have to apply to the roadway. So we see that a lot of counties are taking this advice to heart and they are applying more brine relative to road salt. So we see the proportion of brine to road salt increasing over time. And this is just for Montgomery County, but we see that this trend applies to all 6 counties that our watersheds fall within. So we were curious if increasing the amount of brine actually leads to less mass of chloride in the watershed. So we compared 2 years that had similar amounts of snowfall and also similar number of events, of snowfall events that were greater than 1 inch. So we compared 2015 and 2018. We see that in 2015, they applied more road salt and less brine, and there's also a greater mass of chloride that was applied to the watershed. And then in 2018, we see that they applied more brine and there was an overall less mass of chloride that's applied to the watershed. So based on this limited example, we're seeing that when these transportation departments apply more brine, there actually is less chloride that's being applied to the watershed. So this can help reduce some of these chloride concentrations and help them maybe not increase as quickly as they are. So in conclusion, flow normalized chloride concentrations are likely going to continue to increase over time, especially as impervious surface cover is increasing in these exurban and suburban watersheds. This will lead to streams with chronically high chloride levels in the very near future. So it's important that we protect forests on the watershed scale to reduce the impacts of impervious surface cover and also start to limit some of the development in these exurban and suburban watersheds. We also see that sodium concentrations are increasing in streams over time, and there's a high corrosion potential of pipes due to historical road salt application. So it's important that we must reduce the use of road salt and ultimately switch to using more brine as a temporary solution to our chloride problem. I just wanted to give a brief thank you to everybody listed on this slide, and in particular, Aqua America for providing us with the data and making this study possible. We couldn't have done it without their help. And if anybody is interested in collaborating in the future, we're interested in expanding this research to more watersheds in more regions. And we're also interested in looking at other water quality parameters such as cations and metals. So feel free to either reach out to me, my email is listed here, or my advisor, Dr. Goldsmith, his email is also listed here. So thank you, and I will now open the floor to any questions.
Hey, Marissa.
Yeah.
Hi, this is Joe Duras with the USGS. That was a great presentation, and I think really timely, and it definitely addresses some of the things that USGS is thinking about on almost a basin-wide scale in the Delaware right now. So very, very, very cool presentation. I did have a question about the land cover data, and specifically, one of the things that and it's more, I don't know, it's just more observational than anything, but one of the things that we've talked a lot about internally is that, there's a lot of controls on state roads as far as what they apply as for road salts. And then there's some controls at the county level and maybe less at the local level. But one of the places that seems really uncontrolled is in like strip malls and places with large parking lots and things like that. So I wonder, how do like strip malls and parking lots fit into your kind of spectrum of your developed data for your GIS? Does that fall into the low density development that you described as being significantly related, or does it fall into like medium density or high density, or is it across all three?
Yeah, that's a great question. Krista, can I come back to your question? Okay. So,
oh, I'm sorry.
Oh, that's okay. I think it's hard to hear on Zoom. So for the parking lots and other impervious surfaces, we looked with that high resolution data set. There's other impervious surfaces listed. So that's things such as parking lots, like sidewalks. That's all the other impervious surfaces that are classified there. So we use that 1 meter resolution data set, and in the mass balance approach, we applied a like a consistent rate of salt application based on something that we found in the literature based on the number of snowfall events. So I think it was like 0.05 kilograms per meter squared base per snowfall event that's greater than 1 inch. So we were able to quantify that. It's as accurate as that 1 meter data set is. So
Sure.
that's how we were able to look at those other impervious surfaces.
Okay, so it was almost more of an area to area comparison then, right? Because it would be
Yes.
the area of the parking lots at that rate versus the area of the roads at that rate.
Yes.
Okay, all right. Okay, thank you. That's good and useful information. I appreciate it.
Yeah. Yeah. Thank you for your question.
And sorry, Chris.
And then Chris's question was, can I talk more about the impacts to aquatic organisms? Right? Is that, yeah. Okay. Yeah. So I have a slide for this. So based on current trends, all 6 watersheds will exceed this US EPA chronic threshold value of 230 milligrams per liter by the end of this century. And we did so by using the trend line to project trends out into the future to determine when these watersheds will exceed this US EPA chronic threshold value. And we see that it's happening as soon as 2032 in Chester watershed. So within the next 10 years, these streams will have these chronically high chloride values, which can have impacts to aquatic organisms. And then it's quickly followed by Crum in 2043 and then Neshaminy in 2048. So it really is a relevant problem, and we can start to see these chronically high chloride values in these streams if current trends continue. And that can have various impacts to benthic macroinvertebrates, amphibians, and fish. Some of the previous literature has shown like increased mortality and then also decreased species richness. So these are some of the impacts that we can expect to see in the future.
Thank you so much, Marissa. That was really, really informative and just a very current issue. That slide at the end also was just really striking. Yeah, that's going to stick with me today for sure. Thank you again. That was great. If anybody has any additional questions for Marissa, feel free to post them in the chat and indicate, or in the Q&A, and indicate that it's for her, and we can try to follow up on those later. I apologize that we are running a little bit behind today, so we had to cut questions a little bit short. Are you sticking around for the morning for those who are kind of in the room? Okay, so, and she'll be with us if you want to try to find her during the break as well, more questions. So thank you again. We will move on now to our next speaker, Joe Duras of USGS, who asked one of those questions just recently. Joe received his bachelor's in biomedical science and chemistry in 1998 and his master's in environmental microbiology in 2002 from Western Michigan University, and started with the USGS in Michigan before moving to Pennsylvania. And he's currently pretty focused on PFAS in his work, and also actively monitoring major monitoring and monitoring projects in evaluating loads and trends of nutrients and suspended sediment. Joe will be sharing a presentation with us today entitled PFAS Monitoring and Assessment Overview from Statewide to Site-Specific Scales. Thank you for joining us today virtually, Joe.
Well, thank you all for the opportunity to come and talk about some of our PFAS work. This is a relatively new topic for the USGS. And for those of you who aren't familiar, our main office is in New Cumberland, Pennsylvania, but we also have an office in Downingtown, and a lot of our work of late has been focused in the Delaware River. And so we've kind of taken on several projects related to PFAS that started around Willow Grove and Warminster, where we've been working for a number of years on various contaminants. PFAS was added, over the last probably 8 years. And then we've really kind of taken on more project work and more federal work also across the state. And so the goal of my talk today is just kind of bring everybody up to speed on some of our current activities, and then talk a little bit about some statewide data that we collected in 2019, 2020 with the Department of Environmental Protection. We sampled the entire statewide sampling network in surface water. And then I'll talk a little bit about some of our local scale efforts, particularly in the Neshaminy Creek. So that was a good tie-in with Marissa's talk. And I'll talk a little bit about some of the QC work that we're doing also, because I think, with this new topic, one of our big focuses is making sure that we're not just collecting data, but we're collecting data that we understand, and that we can qualify and explain. So I'm going to jump right in and just kind of list off some of our collaborators here. As I mentioned, we do work a lot with the DEP Bureau of Clean Water. Recently, we've added in the Pennsylvania Department of Agriculture. That's a particularly important study because we are actually sampling domestic supply wells for the first time there. We work with 3 branches of the military, the Navy, the Army, and the Air Force, at both the guard level, so the state level, and at the federal level. We work with our USGS National Water Quality Program. Many of you may be familiar with that program, as it used to have a different moniker. It was called the National Water Quality Assessment, or NAQA. That all got wrapped up into one big program. It is now called the program. So things have been realigned, and that's just changed basically some nomenclature. And in addition, we a lot of our work, especially the quality control side of things and the quality assurance of these data collection efforts, has been with the USGS Water Mission Area. So I am a part of the Water Mission Area. Our office in New Cumberland and the other 3 field offices around the state, are also part of the Water Mission Area. And people kind of recognize water as we're the group that runs the stream gauging network and the groundwater network. But we also have some cross collaborations with other mission areas in the USGS, such as our ecological mission area, and to a certain extent, the environmental health mission area as well. We've done some work in particular just with some training and some outreach with the Ohio River Valley Water Sanitation Commission, or SANCO, and that has brought us in contact with West Virginia University Three Rivers Quest, or 3RQ program. So you can see we've got kind of a broad spectrum of cooperators, from academic to DoD to state agencies, and that's allowed us to collect a lot of data, and also to really start to ask, I think, some interesting questions that we'll get into. So an overview, there's a lot of words on this slide, and the reason there's a lot of words on this slide is kind of related to this picture right here. This was 1/3 of the samples that we collected in 2019 being packed and shipped out to our analytical lab. So earlier it was mentioned, just the kind of volume of PFAS samples, and we feel that pain. We understand that need, because we are sending a lot of these coolers full of PFAS samples lately too. In 2019 and 2020, we did, as I said, a statewide sampling. This was of the statewide surface water monitoring network. Some of you may be familiar with that network. It's called the state's WQN, or Water Quality Network. For that effort, we collected samples from 180 unique surface water stations across the state. In addition to that, we did 18 field blanks and 18 field replicates. We collected 16 comparison samples where we did splits between 2 different laboratories, and we even did some sub-replication in there where we sent multiple samples to individual laboratories and sent duplicates to both labs. We collected polar organic chemical integrative samples, or POSIS samples, at 18 sites. That was done in collaboration with the DEP. And prior to any of this work, we collected 50 equipment cleaning blanks on our surface water sampling equipment. This was really to ensure that we could collect a sample that we knew was going to be clean effectively, and that we wouldn't be cross-contaminating samples with our equipment. All of this data that we collected in 19 and 20 is available in NWIS, and then it's summarized in a USGS science-based data release online. The surface water sampling methods are currently in a data series report that probably is going to get turned into an open file report as it's gone through revision. That's some of the comments I've gotten back so far. And then a journal article that is currently in preparation that will be co-authored between USGS and DEP. In addition to that statewide effort led us with DEP to focus in on 20 sites across the state. So not just in the area of Philadelphia and the Schuylkill, but across the state. 20 sites were selected, and those are now being sampled monthly, or they started being sampled monthly in 2021. In 2022, as a result of not detecting compounds at 4 of the sites, we reduced to 16 sites that we're going to follow for about 5 years. And through these 2 studies, now we have kind of piggybacked on that and pulled in some funding from different sources across the country. And we've done a pilot of river continuum sampling. Some of you may know that as Lagrangian sampling, where we've followed the same bolus of water as it's moved from upstream to downstream, taking samples at identified time periods that are linked to the time of travel of that kind of chunk of water as it flows downstream. We did that in Park Creek and Little Neshaminy Creek and Neshaminy Creek. So following that same bolus of water, the data are just coming back for that. We also did, or we're starting an evaluation of wastewater treatment plants that take pre-treated unconventional oil and gas waste or leachate from landfills that accept unconventional oil and gas waste. There's a lot of literature out there that suggests that there could be issues with wastewater plants that accept UOG waste. That UOG waste has been found out west to have elevated levels of PFAS in it and part of the fracturing fluid in the return waters. So we're kind of doing a preliminary assessment of that this year. And then in addition, through some additional USGS funding that we brought to the table, we're going to start this year an assessment of naturally occurring foams on rivers. So all of us have probably been walking along a riverside and seen a bunch of that kind of tan foam that forms. That's a natural process of DOC breakdown, but it turns out that that DOC can be a tremendous sink for PFAS in water. A lot of this work has been done on lakes, especially in the state of Michigan. They've done a lot of this work with the health department there. But we're interested in it as a potential sink and source that might be affecting the loading and might be affecting mass balances in river systems. So we're kind of investigating that as well. The 2 points here that I'm going to focus on, obviously I threw out a lot of information there, are going to be this 2019 and 2020 statewide sampling, and then this 2021 focus on our 20 selected sites. So we're going to show you some of the preliminary data from that study. But I would be remiss if I didn't talk about some of the other work that we have going on that I kind of alluded to in the introduction. So we are part of, as I said, we do work with the National Water Quality Program. There's been a recent publication that synthesized some of the data that we've collected in the Pennsylvania Ohio River alluvial aquifer over near Pittsburgh. This was one of I think, was it 3, 6, 7 aquifers that were sampled in the eastern United States, and those were synthesized in a recent Water Mission Area Journal article, and the reference is there, and I'll provide it again later as well. But one of the kind of takeaways from this, so this is groundwater, groundwater that's used as drinking water, but it's prior to treatment, so this is actually samples from the aquifer. One of the things that you'll see here, it kind of shows the distribution of the well network and the PFAS detection frequency. Our well network, the Ohio River alluvium that we sampled, is right there in the middle, about 60% detection frequency in all the wells that we sampled. But I think that maybe the more important kind of thing is there was some machine learning conducted on this data set. And what they found was that things like tritium, so the age of the water, the younger water being more vulnerable, distance from fire training areas, dissolved organic carbon in the groundwater, the percentage of urban land use, and the sum of VOCs were the top 5 variables for predicting PFAS detections in groundwater. So there's hydrologic variables that affect PFAS, there's land use variables, and there's geochemical variables that affect it. So that's a really important piece of work, and it's, I think, going to guide some of the analysis that we do in the future on our surface water sampling efforts here in the state of Pennsylvania. We also are doing a bunch of defense-associated work. The Naval Air Station Joint Reserve Base in Willow Grove Horsham, the Warminster Knock, those are both AFFF sources, so that is aqueous film forming foam. And Lisa Senior and Dan Good, two hydrologists in our office, published it in 2019, a preliminary mod flow model that looked at the changes in groundwater flow related to drinking water wells actually being taken offline as we recognized that there were PFAS problems, right? So these wells draw a lot of water out of the ground, and that affects the flow of water to streams. So when you suddenly turn off large production wells, then that water goes somewhere, and typically what it does is it shifts its flow path back to a close surface water body or through a fracture to a distant surface water body. So they did some modeling in and around the Willow Grove Horsham and Warminster to look at those regional flow paths. And that's published in this publication here, which I'll reference later. In addition, we do work with the Army, the Letterkenny Army Depot. There's all sorts of great acronyms. You guys are probably familiar with the RCRA acronym, but OBOD you might not be familiar with. This is the Open Burn, Open Detonation Area of Letterkenny Army Depot. The OBOD is a place where they detonate expired munitions. And then there's the ARMD, which is the Ammonium Perchlorate Rocket Munition Destruction Facility. Really great acronyms coming out of the Army there at the Letterkenny facility. But we're monitoring these for compliance with the Army, but also trying to understand things like flow paths that go from these kind of localized areas at the base and the potential that they're impacting groundwater or surface water through runoff. And lastly, just recently, we've proposed some work, a 3-year study at the Pittsburgh Air Reserve Station. The Air Force is really interested in understanding migration of PFAS off of the base there. And so they've contacted us, and we are kind of in the final technical negotiations with them on that proposed project. And finally, I would, again, kind of be remiss if I didn't talk about this quality control piece. One of the important things here is that, we really are focused in on this QC aspect. We need to inform not just what's happening in Pennsylvania, but we need to inform the nation as far as our standardized water sampling procedures, water analysis procedures, that sort of thing. So when we completed the sampling, for this project, we did a spiking assessment, and the data on that is returning, and the questions that we're trying to answer are listed here. And those are: do we lose PFAS to absorption to our equipment? And if so, what substances do we lose? That's a really important question. If you stick, if you're trying to take a composite sample and you're using multiple pieces of plastic or Teflon in the water, do those compounds that are longer chain or shorter chain stick to your plastic and not make it to the lab? And then when we know our equipment is exposed to PFAS, can we clean it? So we did some spiking and cleaning exercises where we spiked it at low levels, more environmental, or what we would expect at kind of a diluted environmental concentration, and then some higher level concentrations that we would expect to see near bases that might have AFFF runoff. We tested both poly and Teflon surface water sampling gear, and we also tested 6 different groundwater pumps to make sure that we can, again, collect clean samples. This is an extension of the blanking exercises that we did. As I mentioned, we did 50 equipment blanks in our surface water equipment sampling in 2019. I mentioned earlier, we are working with the Pennsylvania Department of Ag. We're doing our first foray into domestic well sampling, and we're pending data on that. And then finally, we are, working with the mission area on some capacity building. We have a chemist, Dr. Emily Woodward, who's over in our Pittsburgh office of the Pennsylvania Water Science Center. And she's helping Dr. Andrea Tokranov to establish an Orbitrap high resolution LCMS at the Leetown, West Virginia office of the Eastern Ecological Science Center. So there's one of those eco mission area centers that I mentioned earlier. And their focus is really going to be on target, but also the interest is on non-target analysis. And they'll do things like total oxidizable precursors analysis, a standard isotope dilution methods following, some of the EPA water methods. But they're also interested in doing special tissue and blood analysis at that lab as well. So I'm going to talk now, focus in on the 2019 sample, and I'm going to talk specifically about our sampling methods, because it's both a method that we use, but it's also kind of a result that has come out of this. One of the big questions when we started this work was, we started to look and summarize sampling methodologies from around the country. And all of them had extensive, very intense rules about special attire and foods that you could eat the day of, and what products you could use, and whether you had to cover your seats with plastic, or whether you couldn't go to a Burger King or eat a burger wrapped in paper, or a bunch of really intense sampling. And that's a really hard thing to implement at a big scale. So what we did is we said, well, we take a lot of trace organic samples, and so we're going to follow the same procedures that we've used for trace organic samples. However, we're going to add a couple of things to it. One is we're going to use specially selected and specially cleaned equipment. In this case, what that meant is that we're going to use high density polyethylene equipment that's been cleaned with methanol. And the other thing that we're going to do is that the person that's opening the sample bottle should be wearing something that covers their skin and clothes that might be coming in contact with bottles. It's a little different than our normal procedure where we just use kind of wrist length nitrile gloves. But in this case, the concern is that, you might get some contamination from clothing, which is often treated with different types of PFAS. Other than that, we're doing normal cautions. You're only opening the bottle when you're ready to fill it. You're closing the bottle promptly. If you're dropping a bottle, you're getting a new one. You're avoiding contact with the inside of the bottle, and you're avoiding spraying or creating aerosols. So those are kind of the methods that we used in this study, and those are being summarized right now in the report that I mentioned earlier. We did 4 different kinds of sampling. We did wading sampling, bridge and boat sampling, lake sampling, which is obviously distinct, and then some direct bottle filling, where that's really a wading type in a super shallow stream where you can't use the normal equipment. The direct filling is maybe what people are most familiar with, where you take the analytical bottle and dip it beneath the surface and it fills up. The wading, bridge, boat, and lake sampling is done with the camera and a direct fill from that camera sampler. And then the bridge and boat and wading samplers are done using integrated samples that the USGS typically uses to collect surface water. So to describe that, we take equal width integrated composite samples. This uses poly HDPE equipment, again, cleaned with our special procedure. We're using, and if you're not familiar with these, that's okay, DH81, DH95, and DH2 samplers. These are the different kinds of samplers that we use. They're basically weights that orient into the direction of flow. If you're on a bridge, you use one of these big things. If you're on a stream where you're wading, you use a much smaller version of the same thing. And the goal is you use the same rate through each section of the river, going up and down through the water column. And what that nets you is really a flow weighted sample where the most water that you collect is from the deepest and fastest sections, and the shoulders, which are typically slower, are gonna net you less water. All of those bottles are composited together in a churn splitter. That water is mixed together and then split out into the analytical bottles before it's sent to the lab. So we're doing a proper number of sections, typically 10 in a stream. Some smaller streams, we might go as low as 3, just 3 sections. And then we're compositing that in the churn splitter, and we're using those special gloves. So the reason that this is important is because this is going to allow us to do some additional analysis with the data once we get it. Speaking of getting data, what were our analytical methods? We used SGS Analytical in Vancouver, British Columbia, Canada. This was not a DEP accredited laboratory at the time, but they were willing to go with that because this was kind of recognized as one of the best. You see the draft method SW 846-8328. That draft method is now US EPA 1633 draft. So basically what happened is they went through they were going through validation at the time. When we used the lab, they were analyzing for 33 PFAS compounds. Now that 1633 method that was just released recently is at 40 compounds. They do use a solid phase extraction and then liquid chromatography tandem mass spectrometry. The solid phase extraction, isotope dilution, and internal standard quantification are used, which is all described in that 1633 method. We had 33 PFAS from 7 categories. And the kind of special thing that we did was we also looked at total oxidizable precursors for 19 of those 33 compounds. I've got a little cartoon here that describes what the total oxidizable precursors are. In particular, if you take a sample, and let's say this sample on the left is your sample before top, which is total oxidizable precursors. So you analyze this sample, and then you oxidize this sample and analyze it again. And so what happens here, and this is the easiest way to explain it, is just give an example. So in this first sample, if you measured PFOA in the water and it was 10 nanograms per liter, okay, and then you add the chemical oxidation and you run that analysis again and you analyze for PFOA a second time after oxidation. What you would see is that, oh, now all of a sudden, after this analysis, we have 15 nanograms per liter of PFOA. So the result from that is that there are 5 nanograms per liter of unknown precursors of PFOA in the sample. And I'm going to show you some data, and these precursors are definitely around. So this can definitely affect the mass that you get at your sample sites. And in particular, I want to state that we focus on mass. That's why we look at stream gauging. That's why that's why we look at sampling at stream gauging sites. And it's also why we take discharge measurements of the stream if we're not at a gauging station. And in particular, it's why we do those integrated samples, right? Is because that is a full representation of the water column, and therefore we can multiply by the discharge at the time of the sample collection and create what we would call an instantaneous load or an instantaneous mass in the stream. So we don't just know the concentration, we actually know how much mass is moving at the same time. And 170 out of 180 of our samples in this statewide effort had stream flow associated with them. And as I said, mass can be computed from that simply by doing concentration and volume. And then you can also then take that and divide it by the entire drainage area that drains to that single point. And you can compute a yield. So yield being the mass per unit area of a watershed that you derive from a particular sample. In order to do that, you need a concentration as stream flow and then the area of the drainage basin.
So sorry to interrupt. This is Megan. Just wanted to give you like a couple more minutes. I know we started late, so we're a little bit off our schedule, but
okay. I had 30 minutes, right? Sorry.
We had yeah, it's basically 30 total, like with Q&A included.
Okay.
So
all right, I've got my timer on.
Sorry about that. Sorry to
no, that's okay. That's okay. So I'll zip through this, and I don't want to like race through it too fast, but so equipment blanks. So these are the 50 equipment blanks that we ran. You're not supposed to read this. That's the whole point of the slide. The thing I want to point out is we had 2 detections in our equipment blanks. They were not any kind of systematic detections. They weren't in the same set of equipment. These were low-level detections. And so we've felt pretty good after doing this that we could clean our equipment effectively. A summary of our field quality control or of our quality control in general. Again, those equipment blanks were good. We didn't have any systematic contamination. In our field blanks, the 18 field blanks that we collected, we did detect PFOS at a very low concentration just above the reporting level once. And we detected the compound 6,2-FTS, which is a precursor compound actually, 2 times at about double the reporting level. In those particular cases, the lab also reported an over recovery of 6,2-FTS. So we're pretty confident that those aren't anything that's systematic. All of these detections, or these 3 detections, were in different samples from different field offices with different equipment on different dates. So it was nothing where we have a real systematic problem with contamination of our samples. So that's great. Some basic data. So you can see here, this is a box plot. The box plot shows essentially the range of concentration in nanograms per liter. We didn't do the kind of typical, shoulders on the box plot. Instead, we just put the points on here. But the bar on the box plot does indicate the median value. For this, we did use a half of the median reporting level, because the reporting level changes sample to sample, as the non-detect to do this summary. We did not use that in our further statistics, but one of the things that you can see here is listed by compound. You can see the percentage of the compound detected, and then the median detection of compounds, as well as some of the higher concentrations. One thing to point out is that PFOA was detected in 70% of about 70% of the samples. And with PFBA, PFPEA, PFBS, and PFOS, also being detected relatively frequently. So yield, I'm going to kind of skip over this because this needs a little bit more explanation. But if anybody is interested, I can share this with them after the fact. The statewide data summary. So I think the one thing I wanted to point out here is that the Delaware River had 53% of the sites that we sampled, which is 34. So 18 sites had 5 or more PFAS compounds detected. Across the entire study area, if you looked at just the kind of percent for the entire state, it was about 40%. So the Delaware River Basin tends to be on the higher side of number of compounds detected. In addition to that, if you look at both PFOS and PFOA being detected, it's near the top, with the Great Lakes kind of beating it out, but the Great Lakes was many fewer samples. So 65% of the sites had both PFOS and PFOA detected. Let's skip over that. I think I'm going to stop there. That's a really good spot to end. That's the statewide. I'm sorry that I didn't get to drill down into the local issues, but I will say some important things. We do see some seasonal variation in local when we collect monthly. One important point, though, is that the time of day in the system that you're sampling can be very important, because we recognize now that wastewater treatment plants can be an important site or an important source in watersheds where they may, where those watersheds may have multiple sources. And so if you're sampling at different times of the day, you may be getting different mass loadings from the wastewater treatment plants, and that can affect your interpretations. So I'm gonna stop there, and I appreciate the time today. I'm sorry that I went, I guess, a little long there. I apologize.
No, I just wanted to connect with you a little bit and didn't know another way to do it other than
that's
being
fine.
kind of a
That's
voice
fine.
of God. So I apologize.
No, I appreciate it. I was looking at my clock there, and I was like, all right, I think I can get through these, but I appreciate it. I want to keep us on track. So if there is time for questions, I'm happy to take any.
You have a very rapt audience here, Joe, which you can't fully see. And I feel bad that, we kind of can't fully, appreciate that in this hybrid world that we're in right now.
Oh, that's okay. I think we've gotten used to it a little bit.
Does anyone in the room have questions? If you do, maybe you can come up to the podium. It may be an easier way to just share that question directly into the mic. I believe we do have a question. Just a second.
Can you see me, Joe?
I can hear you.
Okay. Joe, my name is Glenn Evers. I formerly worked with DuPont. I'm a research chemical engineer.
I see you now.
Yeah. So if you want to get a quick shot of me again, you can go to John Oliver tonight and see the PFAS series. They managed to pick me off on one of those. But anyway, during my congressional testimony, I sat next to the head of the Department of Environmental Protection at New Jersey, and she was very frustrated and wanted to know where these fluorochemicals were coming from and on farms and in the wells, and just where do they appear? There are no Air Force firefighting operations going on.
Sure.
And so I could give her probably a half hour of lists of where to look. But I said that the most important thing to look for was the fluorine atom,
Mhm.
because you can't escape that. And
Yep.
in your mass balance, you've seemed to identify fluorine substances other than PFOS, PFOA, and the other
Correct.
top items. And those are very critical.
Yep.
So first, I want to congratulate you on the rigorous, you're absolutely rigorous on your sampling technique. You're doing an awesome job.
Thank you.
I would caution you on one thing that you may not know, and that is in both blood sampling and in actual sampling in the lab, there are micro pipettes.
Oh yeah.
And these
The
micro
filtered
pipettes,
pipettes are a big, big source.
right?
Yep.
So you got to be careful to make sure that those anti-clingy drip pipettes don't carry any fluorochemicals.
Yeah,
with it.
it's interesting. They treat the inside with them, and some of the filters that they put, if you're using anti-aerosolizing tips. Yeah, so one of the first things our National Water Quality Lab did, Glenn, was they did blanks on all of their pipettes and all of their equipment, and they had to change the tips that they were using because of exactly what you just described.
Good job, good job, good job. So I think you're right on in testing foams, because it is definitely a concentration effect that happens with the fluorochemicals. When you go out into, don't neglect the agricultural areas. There's a recent study of how the fluorochemicals were accumulating in the from biosolids applied to a farmer's land, and then that was transferred into food products, into cattle, and then that was transferred into meat, where they had to do a recall.
Yep.
So, but the question of where it comes from in paper mills, where the PFAS comes from on agricultural land is from the recycle of paper pulp. And that is used as a carrier for agricultural chemicals. So you can find it broadly across the United States. So don't ignore the agricultural sources. In the urban sources, consider that a good portion of the PFAS chemicals were used in manufacturing water and oil repellent chemicals for fabrics. And the method of application was to simply pour a bottle during the rinse cycle and then heat it up and then just let it go and adhere to the fabric. But most of the water that was drained went directly out into the creeks and in the rivers where you're sampling.
Right.
Unfortunately, they are polymers. They're called terpolymers. And these terpolymers settle to the bottom of your creeks. So I would encourage you that while you're doing your sampling, dive a little deeper down into where you think 3-5 years ago where that sediment is, to see if you can find the PFAS.
So I will say, Glenn, one of our, as part of that foam study, because it is looking at partitioning in the environment, we will be sampling the sediment in the stream as well. So it'll be.
Well, that was my question. You did you answered my question. Thank you.
Yep, it will. That's good. It's a conversation question and answer.
Yes.
We will have we will have the foam body sampled directly, the water that's flowing directly underneath it, and then the depositional areas in the stream, right? Because one thing to keep in mind is that, and you know this, I'm sure, but like, where sediment deposits and where chemicals deposit with sediment, if they are attached with sediment, isn't always straight down, right? The center of the channel is not always a great place to do that. It's oftentimes in the slower water at the sides of the channel. But to the point, we're also, when we take those foam samples, we're kind of trying to think about it as a mini mass balance, where we're doing the exact same thing directly upstream, taking discharge measurements, sampling at the foam body and in the depositional area by the foam body, and then sampling directly downstream as well, so that we can look at any potential mass loss into the foam, or there's also the possibility that as foam dissolves, it's leaching PFAS back into the system, right? And so that's the approach that we're taking, and it's the first time USGS has looked at this level at it. I think we've done just a few foam samples in the past. The other thing that we're really interested in with this is characterizing the body and the density of the foam, so that it's not just we took a sample out of the middle of the foam, but rather we try and characterize the foam itself as a whole mass. So I think we just got the hook, Glenn. I appreciate your comments. Thank you.
Thank you again so much, Joe. And yeah, I feel like you and Glenn could probably spend the rest
Yeah.
of the morning.
No, I'm sorry that I couldn't be
conversation.
there because we would have had a good lunch together.
That was great. Yeah, thanks again. Our next presenter, Sita Coleman Camula, is the co-founder of the Delaware Nonprofit Center for PFAS Solutions. And her full bio is included in your packet. She is a self-described serial entrepreneur and also a former senior vice president of Basel, a Royal Dutch Shell and BASF joint venture, and has had a lot of different adventures along the way. But she's currently leading the Center for PFAS Solutions, and I believe her title's shifted a little bit since we first posted this, so I apologize, Sita, that didn't get captured here, but she'll be presenting today on some benefits to utilities and some different methodology.
Thank you, Megan, first of all, for accepting my latest update this morning at 6 o'clock. I have a title, but what I'm going to talk about is a little bit different because I don't know if many of you know, but Delaware just announced its MCL for drinking water. And it is open to public comment period. They started to roll it out. It got me thinking about one of the areas that we focus on in addition to testing and monitoring for PFAS in drinking water, surface water, and also in biosolids. One of the other things we do is actually try and find effective, cost-effective treatment solutions for our drinking water customers in Delaware, whose water we've been testing. So I'm going to share with you some of that thinking, but just, I think it's fresh and there's a lot of questions. I don't have a whole lot of answers. Where's page down? Okay. Oops. Yeah, I did that. Not moving. I should just do this, right? Ah, there it is. So yeah, we specialize in detection and quantification. We are a 501c3. Much like this lab here, we started 1 week before COVID shut the world around us, literally bought the equipment and had it commissioned on the 7th of March. And with a very small team of 4 people, we've kept it going, and we've been doing work, quite a lot of it, out of a small lab in Newcastle, Delaware. So, but we're not just another testing lab, as I already mentioned. That is our team and our board members. We really want to acknowledge the Longwood Foundation that gave us the grant to get us started. So on that list, the person that I really want to highlight is Dr. Charles Powley, who is really one of the very few experts in PFAS detection, analysis, and speciation. He is from a DuPont Central Research. Last week, we got a call from a partner, very strong, is emerging to be a strong partner from Europe, who called him, or who got in touch with him to say, in Belgium, the methods he developed for extraction, it's actually called Powley method, are in use. Could we help them? So it is an expertise we want to preserve, and we're happy to use that expertise. And you know, all the things we talked about earlier on in Dr. Burris's presentation about contamination and pipette tips and 6,2-fluorothioaminsulfonate, we've been through all of that, and Chuck has gone through that and made sure that our data integrity is really sound in terms of contamination and loss. So really, I want to talk to you a little bit about, you know, how much or what PFAS have been found in Delaware and some of the ongoing work we've been doing with the 2 drinking water methods, as well as the 1633. We recently, Chuck has actually set it up and validated the data. And in addition to that, because I thought I was coming to Aqua, I'd like to talk to you about the treatment systems we've tested for drinking water in the vicinity of an Air National Guard site. If I have some time, I may be able to share with you some of the innovation of a new PFAS product, but I don't think I'll get to that. So PFAS have been found, Newcastle Air National Guard site, that's really very close to our lab. There are several wells, drinking water wells, that belong to two suppliers, Newcastle Municipal Services Commission and Artesian, and several of those wells have very high levels of PFAS, close to 34 parts per billion. There was another one in the town of Blades and in Dover Air Force Base. And more recently, USGS released a report that did a statewide sampling. And basically the statement says the widespread detection of PFAS throughout Delaware, significant number of detections. And there's several exceedances over the EPA health advisory level. So we do have several challenges in Delaware about PFAS in groundwater, but also some of our recent work shows that there is PFAS contamination in some of the surface water sources, which we did with 1633. That's where we are, and I just wanted to show you how close we are to the sites near the Delaware Air National Guard. All of those are the impacted wells. And when we started the lab, we started to see quite a heavy signal for 6,2-fluorotelomere sulfonate. We finally tracked it down to the nitrogen concentrator that was basically taking the air in our lab had sufficient amount that our nitrogen generator was pulling it out, and it was swamping the signals, but we found a way now to really correct for that. This is just a slide to show you that the CDC released the study of PFAS in blood levels of several people they studied. And what is really I question why there is so much PFHXS. That's because, well, there is a lot of it in the legacy AFFF, but this is after several years, right? They've been consuming this water for several years, and there's still quite a lot of it in the blood. That's really, I think, speaking to the bioaccumulation and the long half-lives of this chemical in people's blood. And as far as I know, Maine is one of the states that actually has PFHXS in their MCL, right, Ryan? Yeah. Okay, so we do three kinds of work: PFAS testing and treatment. And really, we do spend a lot of time doing the third part, which is sharing our research with all the stakeholders and publish, because we are a nonprofit. So a little bit about the water quality testing we've done of the contaminated well water around the Newcastle site. Municipal Services Commission of the City of Newcastle supplies about 5,000 people. And in 2014, they installed carbon towers. And it's very, very close to the Air National Guard site. So it's quite, I think it's very highly unlikely that water. And we can also see that in the pattern that it is contaminated from AFFF use. This is a little bit about, bragging our capabilities, precision accuracy levels, well above that of standard EPA methods. We do use stable isotopes. We can include both 533 and 537 in one test, and our method report limits are about 2 nanograms per liter. And we can also accommodate different sample sizes. But the last bullet is the one that we're actually digging into, and that is to distinguish between linear and branched isomers, which also gives you a very good set of information, not only about the possible sources, because you find a lot of branched isomers in the PFOSs that were made with electrochemical process. But also it's important we're discovering for understanding the treatment efficiencies of different products like GAC and ion exchange resin. So this is not the one that I wanted to send. Okay, it's all right. Change the thing. So let me just do this. Yeah, so let me do that. So what when we started to work with the Newcastle Municipal Services Commission, when we first met with them, they told us, and it really grabbed my attention, this is a small water system that put in, out of budget period, suddenly found that their water the PFAS were breaking through above the health advisory level of 70, right through the middle of the budget cycle. And they had to go to the board, they got the money, they replaced it somehow, but they didn't really understand why. And I said, I think it's time to really understand what's going on. What is going on with the carbon towers? What is on the surface of the carbon towers? What are the different analytes doing that are in the inflow water? So we worked with Adam Redding, who I have to acknowledge, who is the engineer from Calgon Carbon, who is actually the supplier of the carbon to Newcastle, and said, could we set up pilot plants with 4 different PFAS treatment products, and over time collect samples every 2 weeks, not every quarter, but every 2 weeks, and start seeing how they actually flow through. When do you start seeing these things coming through above the method detection limit? And when do we see what's called saturation? And when do we actually see exceedance? So I'm sorry, the slide's not up there, but I started to realize that I didn't understand the word, what breakthrough meant. What does breakthrough mean, right? So instead, I came up with these 3 things, and I just wish that I had that slide. It's the wrong one. It's okay. So let me take you through a little bit of what I meant by. So the green line at the bottom, that's really when you're starting to see, in this case, PFBA. It is the smallest of the PFASs that's there, coming about the method detection line. So the green line at the bottom. And then you see that, over the full scale number of days over a period of time. So the bottom axis is a measure of time. The other axis is the PPT of the C4s. And in this water, there is 54 parts per trillion of PFBA in the influent. And what that top green line shows is, to me, after about 350 equivalent full-scale days, basically that particular material is saturated or is no longer able to remove the PFBA. So after that, it's just starting to come out, right? Till then, it's holding on, and PFBAs are removed, but after that point, they're not. But what's more interesting is it actually starts to go up as well, which is starting to tell you that the shorter chain PFAS, PFBA, is getting absorbed, but also getting knocked off, right? They're getting knocked off. And that's a known thing in the chemistry of GAC. So we start looking at the C5s, the PFPEA, and the longer chain ones take a lot longer to get saturated. So in other words, the GAC is able to interact and absorb the longer chain ones better. So it's like, time to what I call saturation. Think of that line at the top where it says 150 is the initial concentration. Then it's close to like beyond 350 days, it's still going. It's able to keep and not release or just simply absorb. But then you go down to the C6s, and C6 in this case has 200 parts per trillion, and it's still going. I mean, there is still no real saturation point of the C6s. What's also interesting is the time time for the MRL. So in other words, for it to go beyond the method detection is also 125 days. So, it's still good to 125 days. And after that, it's saying, oh, okay, I'm going to start absorbing, and it keeps going, right? It's still good. It's still good as far as the C6s are concerned. And when you come to the 2 that we are focusing on, the health advisory is focusing on, PFOA and PFOS, what you see is in this water, there's 890 parts per trillion of the 2 analytes together. and is nowhere near the saturation point. If you look on the opposite case, about 180 ppt, we've only been able to show you to 450 days. It still has not reached saturation. However, what we are calling today as breakthrough is actually an exceedance level. 70 parts per trillion is what the health advisory says. So what that means is that when we see above 70 parts per trillion, we're saying, we need to change the GAC, right? And roughly today, and that's about right, I think most of you, if any of you are operating any of these towers, you're probably changing your GAC towers once a year, maybe a little bit longer, depending on the quality of the water. But if you drop it to 40, or even, I had another graph, I'm sorry, it's really a different presentation than the one I had. Okay, if the health advisory is going to be 20, what you see is that you're going to now change the GAC maybe twice as fast as what you're now doing today in this particular case. Okay? There's all kinds of modeling we're doing. That is, I come from a world of greenhouse gases and global warming. It's really where I started my sustainability. What this implies is if you're going to continue to use GAC, we're headed for a problem. We have to really redesign and think about treatment trains that can deal with some of the ones that GAC, you don't need to use GAC for, right? And this could be the lower energy content materials and perhaps even cheaper to get rid of most of the things that you don't need the GAC for. And that's I'm simplifying an awful lot of science here. I really looked at this and I realized that I have no comment about where the HAL should be or an MCL should be. Whatever it is, we better get the redesign of filter systems, or we're creating an unintended problem of going towards a high energy use system. Okay, a little bit about 1633, just because I have to put a plug in here. We can do all of those. That's the method. I don't want to show the surface water. So since there is a talk afterwards about biosolids, we are finding some very important results of, this is water from farming soil that's been treated with biosolids. We used method 1633. And if you can read the PPT levels on the other side, some very heavy, high loads of PFAS we're seeing in the bordering streams on the farms. And we're starting to do some biosolid soil cores and also seeing, and I don't have time to mention, but I'd love to come back, seeing some partitioning going on of the longer chain and the shorter chains through the column of soil as it's going through. So I'd like to just stop here to say the only thing I want to say because Aqua PA treatment is really, I think it's really important for us to get a full picture of how the various analytes, not just break through the way, what time does it reach saturation? When is it going above the MRL? And what is the implication of an MCL that could be lower? Even more so, in the case of Massachusetts, it was a mix of 6 analytes, shorter chain ones, right? It has C4, it has C5, C6, C7, C8, C9, C10. How are they going to be behaving through the filter systems that we're using, right? When will we know what analytes actually are going exceedances? How will we have any predictability for the utilities, costs as well as predictability for their carbon footprint and energy? These are important questions, and we hope to be able to pursue that, and we'll be glad to share these results. As I said, we are a nonprofit, and we continue, and we love to do this sort of stuff. That's it. I have time for questions. I'm mindful of the 5-minute call. Questions, anybody? Wow. Well, yes. So in the case of this water, it's just amazingly good water. Very low metal salts, very low DOC, very low dissolved and total organic carbons. It brings tears to my eyes to see this water. I mean, we measure, of course, I think I showed that we've been doing all the metal salts, nanolytes, just the standard method. It's beautiful water. The thing that's there a hell of a lot of is, are these 9 PFAS. So it's really only pertinent for this particular water quality I'm talking about. And it will be very different. These curves will be very different to surface water.
Sita, this is Joe Duras with the USGS.
I'm sorry, you want to come here?
Do you mind if I ask a question?
Oh, sorry, yeah. Who's that? Joe.
This
Oh,
is
hi,
Joe.
hi.
Hi. Hey, so I thought it was interesting. I'm glad you showed that biosolid slide, and I know Glenn mentioned biosolids too, and agricultural kind of areas, and that's one of the reasons we're really thinking about domestic supply wells as well as public supply wells. But my question was actually about, you showed a little bit of data that was, I think it said like stream bank adjacent or up to the stream, edge of stream, something like that. And that's something that we're thinking a lot about. And I guess I just wanted a little bit more information about what the situation was when you sampled there. Was it that there were biosolids applied right up to the edge of the stream?
Yeah, so let me give you, I rushed through that because I was
No, that's okay.
It is a study that's being funded by the USDA Foundation for Food and Agriculture. And there's a little bit of it on our website. It's a 3-year study we're doing jointly with Stroudwater Research, who have partnerships with farms. So the samples, the study, I'll be glad to share with you the rest of it too. The samples where we took samples on farms that used, it was a survey, we surveyed the farms to see, which ones did apply biosolids for years and those that didn't. Very short summary, the ones that used, 2 of the farms had significant, so, I said, is this real? And said, yeah, it's way over the contamination. So it's not contamination of the sampling. It's not, gloves or anything. 2 of them that did apply biosolids had, the data I showed you, had PFASs, the particular mix of the 1633 in the well water that was being used for drinking. They were found in a nearby brook, and then the soil cores were taken by Stroudwater Research using the methods that they used. I'll be glad to share with you. It's a 3-year study. I think they intend to place lysimeters. Also to follow rain events and things. So this is a field study. We just finished maybe the first 9 months because again, we started during COVID.
Yeah. It's been a challenge the last couple of years.
I'd be glad to, we really love to learn from what you're doing, Joe. I think I made a note to see that, we'd like to talk to you.
We should connect because, some of the things that we're thinking about with the foam are, once it's in the foam, that's a potential vehicle that it could actually distribute to the stream bank, right? Like, so it could get out of the stream if it's blowing.
Yeah, Jennifer Field has done, as you well know, has done a fair amount of work on the way they're partitioned, also in the air-water interface, not only in the foams and how the front moves. So
and we're starting to work now with our atmospheric deposition program to start to look at deposition of PFAS as well. So it's
so we're not doing anything on foam, but just basically even just to do on the farms itself is a ton of questions, as you can imagine.
Well, let's connect, Sita.
Sure.
Thank you. My question is more geared toward how to equip water systems as treatment is required, as MCLs are developed. You had mentioned inefficient treatment trains, really some emerging technology. My question is, do you have any recommendations? I work with rural water companies, rural water municipal authorities. Is there a concise resource or a concise group of resources that I can point them to make sure they're at the cusp of technology rather than installing really outdated treatment?
So that's exactly what we are asking ourselves as a nonprofit. What can we do to help, particularly the smaller systems, recognizing that, standard sort of data from the vendors, they obviously haven't tested it for this guy's particular water from Georgetown or, Selbyville or wherever it is, right? I mean, it's going to have very different co-contaminants. So we are recognizing that we need to have such a resource. And we've been investigating, what would be the right kind of scale to do some preliminary screening of. There are 10 different, all the different ion exchange resin suppliers. There are so many grades that are coming. How can we empower and enable these people to even say, hey, I want to talk to two, just these two out of these 12. So some resource, and we're thinking of setting that up in our lab, but we'd love to work with, other people. There are 3 scales to do it on, and bench scale, and then rapid small scale RSSCT, it's called, and the other is the pilot scale that we did. Now, obviously, the pilot scale is the one that you'd use for a direct scalability and, hydrostatic pressure, the rate at which it's going. So if you wanted to know that, you'd go pilot. But we're thinking since we're small, we could do an RSSCT setup or even smaller, right? You can also, there are papers that show how they can be translated. We're about to go to somebody, the state of Delaware, to say he would like to build that sort of thing, particularly for the smaller systems, and give quick answers rather than engineering design ones, which you can take it further if you were Aqua, but we at the interface of the analysis and treatment, which is where you need to really get that information, we could help, because we can analyze and get the full picture and say, based on our chemistry, because we have chemistry knowledge, we say, let's screen these 5. I think that's what we really need. And you hit the thing right there, yeah.
Other than filtering, how about oxidation, like supercritical oxidation? That's still in the research stage, or is that?
So I differentiate between removal and destruction. That's a whole another area, right? You need to be able to remove in water that is at tens or 20, 100 ppt and bring it to a more concentrated level, either through adsorption on carbon ion exchange or reverse osmosis, and then you can destroy. But if you wanted to destroy in, groundwater that's at 10 or 20 ppt, it's not. You would be creating a greenhouse gas problem.
In the room and virtually, we're going to take a 10-minute break. Our next presenter is Tom Sweeney, who's a soil scientist with Pennsylvania Department of Environmental Protection South Central Regional Office. He's one of 2 biosolids coordinators in the region responsible for permitting, training, and oversight activities related to land application of biosolids. He has a BS in Environmental Resource Management from Penn State and a master's in Geoenvironmental Studies from Shippensburg, and he's also a licensed sewage enforcement officer. He'll be sharing a presentation today entitled Land Applications of Biosolids in Pennsylvania, Understanding Permitting and Regulatory Requirements. Thank you so much for being with us today, Tom. I'm going to hand it over to you.
Thank you. Good morning. Just to give you an idea, I work in the South Central region of Pennsylvania. It's the 15 counties in South Central Pennsylvania. Last year, there was approximately 45,000 dry tons of biosolids land applied in our region and about 26 million gallons of residential septage. A quarter of that biosolids came from out of state. Maryland and Delaware were the 2 primary out-of-state sources. And another quarter of that came from out of region. Most of the biosolids generated here in the southeast part of Pennsylvania is land applied in South Central. And we've had people complain in the past, why are you trucking all those biosolids from Philadelphia and spreading it to farms in Lancaster? Well, that's where the farms are. So we do see a lot of biosolids land applied in our region and have for a number of years. So the purpose of the presentation was just to talk about our regulatory requirements and a little bit of the oversight of what we do with regards to permitting and inspecting biosolid sites. So the first thing I'll talk about is what are biosolids? Okay. So biosolids are sewage sludges that have been treated to meet the land application standards. So there are state and federal requirements for treatment that have to be met in order to be able to be considered a biosolids. So biosolids are sewage sludges. These sewage sludges can come from either a municipal wastewater treatment plant through the treatment of their wastewater that enters the collection system, or wastewaters that are pumped out of residential septic tanks. Okay. Now, biosolids would not include any grit or screening. So any of those materials need to be, separated from the biosolids and disposed of at a landfill. Okay, so biosolids are basically sewage sludges that have been treated to meet state and federal standards for land application. Next slide. What biosolids are not would be manures, food processing waste, industrial waste, or any mixtures of sewage sludge with any of the above. The term biosolids is really being used a lot lately to cover a bunch of different materials that are organic waste that are being land applied. But for the purpose of our regulatory program, biosolids are sewage sludges, either from a municipal treatment plant or septic tank pumpings. These other waste products are land applied and beneficially used in Pennsylvania, but they wouldn't be permitted or considered biosolids. Next slide. So a regulatory authority, there are federal standards. That's the EPA 503 rule. These standards were developed and published in 1993. The 503 rule primarily focuses on the quality of the biosolids. And from the 503 rule, we adopted those quality standards, but added additional management practices to our state regulations. So in 1997, we revised our permitting scheme under our municipal waste regulations, Chapter 271, Subchapter J, where we allow for the beneficial use of biosolids through a general permitting process. So most wastewater treatment plants and residential septage that's land applied in Pennsylvania is done under a general permit. We have the ability to issue individual permits for certain facilities or sites that have unique situations that cannot meet the general permitting process. The reason why our regs are in our municipal waste regs, because under the Solid Waste Management Act in Pennsylvania, sewage sludge is a municipal waste. So these regulations are adopted under our Solid Waste Management Act. However, since most wastewater treatment plants are permitted with NPDES permits or other processing facilities, the Clean Water Program is primarily responsible for the oversight. Next slide. So we recognize the benefits of biosolids, that the biosolids contain nutrients, it contains organic matter, but it's also a cost savings to both the generator, but also the people receiving biosolids. I was on a farm yesterday talking to a farmer. Nitrogen fertilizer costs have doubled in the last year. And this farmer basically told me that he cannot farm without the free fertilizer he gets from the biosolids. He can't do it. So he does bring in biosolids from a number of different sources to spread to his farm, his family farms. But he is concerned. The PFAS was an issue that was raised with him yesterday, and he just was asking, well, what should I be concerned about? So we're aware of that. We are aware that while the biosolids has a benefit, there also is this balance that we need to do to protect public health in the environment. Next slide. So the types of beneficial uses that we permit and see in Pennsylvania, the primary beneficial use activity is agriculture, using biosolids as a fertilizer. There is a lot of mine reclamation going on using biosolids in sort of the anthracite and the bituminous areas. Forestry, not a lot of forestry work with biosolids in Pennsylvania. And then we also have gardening and landscaping. We do have a class of biosolids that we permit called exceptional quality biosolids that can be used, can be sold or given away and used for landscaping. Next slide. So the benefits, primarily, we're looking at the nutrient content of biosolids. So all biosolids contain, certain levels of the micro and macronutrients that plants need to grow. Our primary concern is with nitrogen because we want to make sure that we're balancing the nitrogen needs of the crops that are being fertilized and not over-apply nitrogen that could lead to groundwater contamination from nitrates. So our regulations are geared towards what we call an agronomic loading rate. You analyze the biosolids, determine the amount of nitrogen in the biosolids. You know how much nitrogen that crop needs to grow. You only apply enough biosolids to supply that nitrogen. There is also a significant amount of phosphorus in biosolids, and it's actually, generally for every dry ton of biosolids, you have about 25 pounds of available nitrogen, but you have about 95 pounds of phosphate, P2O5. Plants don't need as much phosphorus as they do nitrogen. So what we've seen over time is as you apply biosolids to meet the nitrogen needs, the phosphorus level in the soils are going up. Okay, so we are aware of that, and we want to make sure that we are managing the farm and the site to make sure that that phosphorus stays where it's applied. We also, with land reclamation, because of the drastic disturbance that's taken place on those sites, we do allow application rates much higher than agronomic rates because we essentially are trying to replace a soil and recreate a soil ecosystem on bare rock. So the department does allow higher application rates for land reclamation in order to make sure that we can successfully reclaim these disturbed areas. Next slide. So our general permit process, essentially any generator, and these are the wastewater treatment plants or a septic hauler, needs to apply and receive a permit from the department before they can land apply biosolids. They do this through a notice of intent, which is the permit application where they apply for the application, the permit that they can get coverage under, provide us the documentation that they can meet the quality criteria of our permits, and then we'll review that and make a decision. Next slide. So the three general permits that we have is the PAG 07, the PAG 08, and the PAG 09. The GP7 is for EQ biosolids. Those are the highest quality of biosolids that can be sold and given away. The GP8 is for non-exceptional quality biosolids, and this is the type of biosolids that's typically generated from your average wastewater treatment plant that does not have sort of advanced solids treatment. And then the GP9 for septage. We do allow septage haulers to land apply septage, but that septage does need to be treated and it has to be screened. So the permits can only be issued to the generators. So we do not permit farms. We permit the person's land applying or generating the biosolids to those farms. Next slide. So the three quality criteria that we have, and this comes directly out of the EPA 503 rule, are the pollutant concentrations, pathogen reduction, and vector attraction reduction. Next slide. So the pollutants that we require to be monitored are, here on this slide. These all came from EPA through their 503 rule that was developed using a risk assessment process. Pennsylvania added PCBs because we felt that PCBs were still a contaminant that was in the environment and was still showing up in certain wastewater treatment plants. So we included PCBs in our list of pollutants. The EPA risk assessment was, looked at 11 different pathways and determined based on those pathways and based on nationwide sewage sludge surveys that certain of these pollutants could be toxic to plants, animals, or humans. So that's why we have both concentration standards, but also cumulative pollutant loading rate standards. So how much can be in the biosolids at any one time, but also how much can accumulate in the soil over time and still make sure that that farm field is safe for future use. We do require all generators at wastewater treatment plants to perform a hazardous waste determination, and that can depend on the size of the facility. Small municipal treatment plants that only have homes connected to it, they can basically certify based on their knowledge of their collection system that they're not hazardous. Larger wastewater facilities or facilities with trucked-in waste programs, typically we want to see a TCLP to take a look to see what additional parameters might be in their biosolids beyond the pollutants that we regulate. Next slide. Pathogen reduction. So under the 503 rule and the state rule, all biosolids have to be treated to reduce pathogens. There are two different classes of pathogen reduction that we recognize. That's the class A pathogen reduction, which essentially is destroying all pathogenic organisms in the biosolids. And you usually accomplish this through some sort of advanced wastewater solid treatment process like composting, drying, or some of the advanced digestion processes that are out there. The Class B standards are still significant reduction in pathogens, but it is not a complete elimination of all the pathogenic organisms. So with the Class B biosolids, we have some additional management practices that have to be followed. So you meet pathogen reduction basically through some form of treatment. That could be through digestion or chemical stabilization like lime stabilization. You also have to monitor certain indicator organisms to prove that you've met those standards. And typically we use fecal coliform as our indicator organism because we know it's there and a lot of labs are capable of testing for it. So it's been the main indicator organism that we use for our biosolids program. Next slide. So the third quality criteria is vector attraction reduction. So vectors would be any organism that's capable of transmitting diseases. So the idea with vector attraction reduction is we want to treat or stabilize those solids so that when they're land applied out on the farm field, that they're not attracting these vectors. Primarily, vector attraction reduction is met through treatment at the wastewater treatment plant, but we do allow for incorporation or injection on a farm field in order to create that sort of physical barrier to vectors. Next slide. So our EQ biosolids, the highest quality biosolids, these meet our Class A pathogen reduction, a treatment vector attraction reduction process, and are non-liquid and non-recognizable as human waste. They can be sold and given away, and they still must be beneficially used. So we still require that EQ biosolids be applied at agronomic loading rates. Next slide. The non-EQ biosolids, these are generally used on farmlands or reclamation sites, but they do require some additional management practices and notifications. Next slide. So we require that for non-EQ biosolids that the department be notified 30 days prior to first application, and that you also notify all the adjacent landowners so that they're aware of the activity. Next slide. So for the non-EQ biosolids, the site suitability requirements is essentially you need to be able to prove the site needs nutrients. So we are going to look at whatever nutrients are already on the farm or being imported to the farm and make sure that there's a need to bring those extra nutrients in. We also want to see that the farm has an implemented erosion and sedimentation control plan. Again, we want to make sure that the nutrients we put on the farm stay on the farm. And we do that by making sure that the soil stays on the farm. So the E&S plan, or the farm conservation plan, is a very critical tool that we use to make sure that biosolids stay where we want them to stay. We also have other requirements for slope, seasonal high water table, and buffers to homes and wells. So again, we want to make sure that the biosolids are properly managed, but still benefit the farmer. Next slide. For reclamation sites, we do allow biosolids to be used for land reclamation. Either that's done under the mining permit or under one of our general permits. Next slide. The site management, once a site's suitable, again, it doesn't remain, they still have certain management practices that they have to continue to follow, like implementing the conservation plan, maintaining the buffers, and the soil pH at 6.0 or higher. That's a regulatory requirement to make sure we don't see any leaching of any of the heavy metals that we regulate. And we also have certain weather conditions where you can and can't land apply. Next slide. Obviously, with any regulatory requirement, there are record-keeping requirements. So all your biosolids quality data have to be maintained at the wastewater treatment plant and then reported to the department annually with an annual report. And that report is due March 1st. So right now, we're going through all the reports for all the biosolids that were applied last year. Next slide. We have a training requirement. One of the things that we did when our current regulatory regs were published in 1997 is we required that one responsible person for both the generating facility and the land applier attend our training course. So it's a 2-day in-person training course. Operators can get 11 contact hours. And we basically cover all aspects of the biosolids regulation from generation to land application. Next slide. Okay, so that was the quick biosolids regulatory requirement. Couple points, we are in the process of revising our general permits. Some of the things we're looking to add is we do want to add a monitor and report requirement for PFOS and PFOA. We don't have a standard, but we just want to have people to start sampling. The other thing we're going to start looking at is doing phosphorus indexing on farms, because we've seen phosphorus build up in the soils. Pennsylvania agricultural programs have this phosphorus index tool where you look at the farm fields and their relationship to the streams and other matrix like soil losses and the type of phosphorus that's been land applied. And this tool will help you determine whether you can continue to land apply in certain areas or you have to back off areas near streams. So right now we're looking at a phosphorus index of our new permits and some PFOS monitoring. So, any questions?
So we've just started this 3-year-long funded study by the USDA Foundation to do exactly what you are trying to do here, which is, monitor PFAS on farms that have used biosolids. And one of the things, and that happens to be in Pennsylvania, one of the things we're trying to understand is you had something about is either sold or given away, right? What is the chain of, I can call it a supply chain, from a wastewater treatment plant to the farm? Are they distributors who mix it all up, the aggregators? In other words, would you be able to track, if you found a, certain set of analytes on a farm in a particular location, would we be able to come to you and say, hey, could we track where these biosolids could have come from? You would? Okay. And we'd love to have you come and give a talk to, I don't know how, but I intend to, continue, because there's a lot of questions we have about in that category, because we just found couple of very important discoveries of PFAS. Thank you.
Yeah, so because So we require, every wastewater treatment plant is required to submit a monthly report of all the sewage sludge they generate and where it goes, whether it's land application, landfill, or another wastewater treatment plant. So we know in Pennsylvania for every wastewater treatment plant where their sewage sludge goes. If it's converted to biosolids and land applied, they have to have a permit, and that permit, we can then track where it goes. Now, certain products like the EQ biosolids, we may not know every individual farm because you could have a case where the farmer comes to the treatment plant, loads their truck, and goes back and spreads it. But there would be a record of that. The non-EQ biosolids, all the farms have to be approved by us. We have to have an annual report, and we go through those reports by farm, by field, by source. So I know Wilmington, Delaware, how much Wilmington, Delaware was spread to what farms in South Central region. Same with Allentown, right? So not to pick on Wilmington, Delaware, but yeah, and same with residential septic. So yeah, we do our regulatory scheme and our record keeping scheme allows us to track, especially the non-EQ, but with the EQ products, we can have a pretty good idea where that material is going as well, because even though they can be sold and given away, most of the EQ biosolids in Pennsylvania still ends up on farm fields because that's where the market is as a bulk agricultural fertilizer.
So with the PCBs, I was wondering what methods they use to analyze it, and if you're doing total PCB or are you getting congeners?
Yes, we're using, that I don't know off the top of my head. But yeah, the PCBs would be total PCBs. Usually they're broken down in the method. I see the results all the time, and I was just looking at them. So yeah, I don't know the exact method, but I can get that to you.
So our next presenter is joining us virtually. I'm pleased to introduce Rebecca Hayden. Rebecca manages projects for Penvest in the Southeast and Northeast regions of Pennsylvania, and also is the president of the Watershed Coalition of Lehigh Valley in a volunteer capacity. And she lives close to me over in Percy Bucks County and has some fun details about what she does in her free time in her bio. I encourage you to check it out. But Rebecca will be sharing a presentation today entitled Penvest Low Interest Loan Program for everyone. So we will hand it over to her virtually. Yeah, and thank you again. I know that we disrupted like some personal plans that you had, that you're joining us from Pittsburgh today because you'd planned to travel today. And I really appreciate you breaking up your day like this and joining us virtually to share with this group.
It's fine. This gives my daughter, who's inexplicably getting a PhD in organic chemistry in Pittsburgh, an opportunity to listen to me talk about my job. So I think
excellent. Women in science,
now I got
we love it.
Okay, super.
Right.
Now, the next thing we're going to see is if this works. So
looking
Megan,
good on our end. Thank you. 20 minutes is the time frame we have for you if you can target that.
I can do it in less than that. Super. Okay.
Perfect.
Good morning,
Thank
everybody.
you.
Now that we've handled all the logistics, my name's Rebecca Hayden. I work for Penvest. We have project managers who cover the state, and I cover the eastern third of the state, the southeast and the northeast. So probably most of you live and work in that area. Tessera Schloop Perry covers the south central. So for Reading and those areas around there, Berks County, she's the person who covers that area. Penvest has been funding clean water projects since 1989. When the EPA was created, there was a state revolving loan fund created in every single state and then in all the territories. So there's an equivalent of Penvest in all 50 states and all the territories. And these are low interest loan programs that were created in order to provide funding to make the nation's waters fishable and swimmable. And we've been giving out funding to do that ever since. This is a case of measles across Pennsylvania that show the different projects that we've funded and their distribution. You'll see in a way that makes sense, there's concentrations of funding around the major metropolitan areas in the state, and then more widely distributed projects in the more rural areas. We fund water projects, drinking water projects, wastewater, meaning sewer projects, non-point source projects, stormwater, and then brownfields as well. So as of right now, we have approved 4,429 projects for a total funding of 10.2 billion. We crossed the 10 billion mark at our January board meeting. And there's around 770 million that were budgeted for the fiscal year that we're in. We offer 4 types of funding. The majority of the funding that we offer is low interest loan funding. And then we offer traditional grant funding. Our grant funds, our traditional grant funds, are all based on an ability to repay. So we target those communities with grant funds that are going to struggle to repay a loan. And we base that analysis on looking at rates and the median household income in the communities that are being served. We're finishing up around this year of special grants that came from the EPA for lead line replacement. And then we also offer loan guarantees for really large projects that we may not have the ability to fund. I don't believe we've actually closed on one of those yet. And so you'll see below, it's cut off on my screen, but I think everybody can probably get a sense of the breakdown of the types of projects that we have funded at this point. So we haven't updated these, but there's 4 application cutoffs a year, and it's always the same. Obviously, the dates roll through from year to year. It's the first week of May, the first week of August, the first week of November. Every now and again, it hits on Halloween week, and the first week of February. And there's between 10 and 12 weeks between the application cutoff and the board meeting date. The one that cuts off right before Thanksgiving is the longest because there's all of those holidays that intervene there. So we offer funding for the categories I've gone through. I think probably many of the folks who participate in SAN might be most interested in non-point projects, but we also do traditional drinking water that includes PFOA and PFOS removal projects. And then we offer funding for ag BMPs, acid mine drainage, green infrastructure. We do a lot of funding for green infrastructure in Philly. And then we have a program that we provide the funding for, but don't run, for replacing on-lot septic systems. That's a direct to homeowner program. And we partner with a Pennsylvania Housing Finance Agency for that. So if you're borrowing money at 1%, there's a major subsidy in that. A 20-year loan at 1% really provides a major subsidy over borrowing at a higher interest rate. A lot of people really have a reluctance to take on any loan funding, but it's pretty difficult to beat, 1% interest rates. And whatever projects anybody is contemplating are only going to get more expensive. So I know that loan funding isn't palatable to everybody, but even at 1%, and needing to be repaid, loan funding is a good deal. So we do the analysis based upon a county cap rate. If anybody would like to find out at any point what the interest rates in your particular county are, you can just Google Penvest County cap rate and take a look at what our maximum interest rates are. But in order to determine grant funding, what we do is what I mentioned earlier, which is we look at a hardship consideration. If after we do an analysis of the cost of a project and its operation and maintenance after the project is completed, we'll reduce the interest rate to 1% for 20 years, or we'll begin to move grant funding into that project to make it affordable. We can't guarantee for any project that grant funding is going to be available. Sometimes it is. We have a fixed amount of grant funding available in every single round. So if, let's say, we have $15 million of grant funding available for a particular board meeting, and when we look at all our hardship eligible projects, there's only 14 million of projects that qualify, we'll be able to fund it all. at the rate that we determined that it was needed. But that's often not the case. Sometimes instead of having $14 million in grant eligible funds, when there's 15 million available, we'll have 30 or 40. And then what we do is we prorate, and we give each project in that round a prorated amount of the grant funding that we have available. Our entire system works online. Our executive director always likes to say in meetings like this that allows you to work on the application or anything having to do with your project at 2 a.m. on a Saturday night. I have no idea why anybody would want to do that, but the whole project management system is web-based. When projects come into us, we review them and prioritize them based upon an analysis by the DEP. The DEP will look at public safety and health, environmental compliance, adequacy, and efficiency. The DCED will add priority to projects if they create additional economic development opportunities, and PennVest itself will prioritize projects that take place in first-class townships, cities and boroughs, and that don't use additional green space that are within an existing urbanized area. So quickly, if you're interested in looking at a PennVest project, I would be probably, for most of you, the first place that you would start. We would go through an analysis of what your project is going to entail. What's the problem that it's going to solve? Let's get an idea of what permits might be needed, what the timeline is, what kind of environmental clearances you might need, what our federal requirements are. And by the time you come to us for an application cutoff, you'll need to have your project fully designed and all the DEP permits will need to be in hand. You can put your project out to bid after we extend you a funding offer. We suggest that folks not go out to bid before that, because not all projects end up being funded with federal funds. And so if you wait to get your funding offer before you go out to bid, you may end up having fewer requirements that you have to meet, such as Davis-Bacon, or funding. Some strictures end up costing more. At the moment, I can't really imagine there's anybody in the physical room or virtual room who's from Northwest PA, but that particular position is vacant right now. I cover the two regions in the Northeast and Southeast. Tess covers the South Central, and Dan McKessick covers the region that I'm sitting in Pittsburgh right now. Our website has an enormous amount of information on it, but I have to say, I don't find it particularly easy to find anything on there, even myself. So if anybody wants any information, by all means, feel free to go and take a look at our website. But if you can't find it on the website, just drop me a line or give me a call, and I might be able to get information to you more directly. There, how was that? That was, I think, 11 minutes. So I have plenty of time for questions. I'm just gonna bring up what's probably in a lot of people's minds. The new infrastructure bill is still being hammered out as to how funds are going to be distributed and allocated with the EPA. And we simply do not have that information yet. How grant funds are going to be distributed. We know there's additional grant funding in the infrastructure bill, but it just hasn't been decided yet. So if anybody wants to know more information about that, I would suggest to kind of keep your eye on press releases and on our website, but anybody can feel free to reach out to me. Give me your contact information if you want to know. I know that we're going to be doing some webinars and PR, on the the new funding once we have answers. People keep calling me and asking me, and I have nothing satisfying to say. So I think I can take questions at this point, Megan. I think I got done way ahead of your timeline, so hopefully I've bought you a little time back.
You have. Thank you, Rebecca. Ellen Kohler is here with a question, so I'm going to pass the mic off to her.
Sounds good.
Hey, Rebecca. So just a
Ellen,
quick
how are you?
question. I think a lot of us are now learning a little bit more about infrastructure funding and how it works at Penvest, and understand that to get a project funded, it has to be on the intended use plan. So can you speak a little bit to how a project gets on the intended use plan, what the process is, how, you know, we could help municipalities make sure that they get their projects on that list, particularly with all this new funding in mind? I think there'll be a lot more interest maybe in
So,
getting
Ellen,
on that in that plan.
That's actually not accurate. A project does not have to be on the intended use plan. Our intended use plan is very broad. So any eligible project that comes to us can be funded. And we build our intended use plan annually, and I'll often reach out to potentially large funding applicants. The city of Philly, I will ask, you know, the city of Philly, we'll ask the city of Pittsburgh, what types of major projects do you anticipate rolling down the road? But any of the projects, Ellen, that you would be looking at, or, you know, municipal clients, they can come to us. Projects come out of left field pretty much on a daily basis. And as long as they're eligible applicants, non-point source, stormwater, in one of the categories that was on that slide that I showed, that project would be eligible. Why don't you ask a follow-up question on that? Because I just want to make sure that what I'm saying is clear.
So is there a certain amount of funding that normally would require being on for a project that would normally require being on the intended use plan, or not even a level of funding?
No, not even a level of funding.
Okay.
So we have taken on fairly short notice several considerably sized projects from the city of Philly. I believe they probably go on the intended use plan because it takes more than a year for these huge projects to wander through. So if the city of Philly comes to us with a $100 million project, it has time to get onto the intended use plan before the money goes out the door, because you don't just pivot on a dime to do a $100 million project. But I get projects in the door from municipalities, from nonprofits, farmers and whatnot, and we turn around and fund those. And now that we have our small projects program, we'll often be turning around certain types of projects in a matter of weeks.
Great. So that's really actually very important information, because certainly other sources are saying that in other states anyway, you need to be on an intended use plan in order to get funded. So that was really helpful to have that clarified, Rebecca.
Right. So, Ellen, you don't have to step back. I'm sure everybody can hear me. Our program, as I understand it, is unique in that we have 4 application cutoffs a year, and the speed with which we process applications, have board meetings, and get funding out the door. So I have no reason to disbelieve that in other states, what you just said is the case. I think that's probably so. We're just, you know, a nimble group here in Pennsylvania. I don't know what to tell you.
Thank you so much again for joining us this morning into, you know, the early afternoon.
Fantastic. And please, if anybody has any questions, I think somebody dropped my email address in the chat. It's rhayden@pa.gov. If you're interested in discussing any projects and mulling through things, feel free to drop me an email. I'm not working today, but I'll be back in front of my desk on Monday. And Megan, I'm disappointed. I was really looking forward to coming and actually speaking to people in person. This was going to be like major excitement.
Yes, we felt that vibe when we took a 10-minute break, and it was just like really a struggle to get folks back sitting down again. And, because it's like so nice to see people in the flesh again. So yeah, feel that for sure. Yeah, miss seeing you in person, but it was good to hear you today. Thanks so much.
All right, take care. Thanks everybody for your time, and feel free to reach out if there's anything I can do for you.
Thanks again, Rebecca. Bye.
Take care, Megan. Bye-bye.
All right, well, moving down our agenda, our next presenter is one of Aqua's own, Mr. Jeff Fickle, production director here, and he's been at Aqua for approximately 18 years now, I believe. And we have like a more, filled out bio in your packet, but those are the highlights. And he is going to be sharing us a story about production and resilience in response to Ida, which hit last summer, and how Aqua responded to that. So thanks so much, Jeff, for sharing, your story here.
Hello, everyone. So the PowerPoint is a bunch of pictures, lovely pictures that you can comment and we can talk about as we go through them. So I'm just going to talk in the beginning about what happened. In September, the beginning of September, a storm came through, and we were not expecting the amount of rain that fell over top of our Phoenixville Pickering facility. I'm just going to go through what I experienced, and then we can talk about some other stuff. If you have any questions, just let me know. So I work for Aqua, Pennsylvania. I'm in charge of all the southeastern water treatment facilities, including Pickering. Plant we're talking about. Pickering is a two-complex system, Pickering West, Pickering East, with the Pickering Creek in between. There's a dam there on 23, 29, 23. So if anybody has seen it, or when I bring it up, you'll see some high-level shots of it. Both facilities can operate independently, but they do have common intakes to both plants. I'll get into that a little more. Pickering West facility is one of our original Springfield or Philadelphia Water Department, not Philadelphia Water Department. I forget our old name. Philly Suburban. I've been Aqua for so long. So Philly Suburban, back like a 1909, 1899 building. It's pretty much in a bowl. There is a dike wall around it. It's flooded a couple times in the past. We've built a dike wall. It's prevented a lot. And I've been there during some storms and have seen foot below the dike wall. It's pretty terrifying. Well, this one actually went a little higher. So what happened was on 9/1, I got a call. I happen to be in Bryn Mawr, where we're at right now, and I got a call that we have some water flowing down the driveway going into our facility. And it was a cause for concern, but it was going into a storm drain, and we were handling it with some Godwin pumps and moving the water around to try and prevent it from getting any worse. And then it started coming down even harder, and we noticed that the Pickering was starting to rise. After the dam, the Pickering Creek goes right into the Schuylkill. So as the Schuylkill goes up, so does the little tributary of Pickering before the dam and the Schuylkill. So as it was rising, it was coming up 23 and coming up the street. And at one point, somewhere around midnight, 1 o'clock in the morning, we were very nervous that it was going to come down the driveway and just flood us that way. So we abandoned ship. We killed the power to the facility. Our main power hub to the facility is on the east side at a higher location. So we sent people over to the east plant, which is what we call it, and electricians. We had electricians in to shut the power down to the west facility. We battened down the hatches, and we left. We went over to the east side. Not me personally. I was here. My management team and all his employees went over to the east side, and when they killed the power, it shut off our Schuylkill intake. So the east was still operating, the east plant, on just the Perkiomen source. Pickering only goes to the Pickering West facility, so that's out of commission. And the Schuylkill, now that we shut the power off, will not come to the east plant anymore. So we were down to one source, but we were still online. Somewhere around 5 in the morning, Perkiomen submerged pretty much the whole lower half of the Perkiomen intake and a couple feet into the Perkiomen pump station. So all of the VFDs and the drives that were in there, they lost power. That shut down. So now we have no intake source anymore. We were down as Aqua, largest facility in southeastern PA, offline at about 5 or 6 o'clock in the morning. So that's when I responded. Well, that's when I got to leave here and go to the plant and go do some work. So now we're on 9/2 in the morning. There's still water everywhere. If you've seen any pictures, and you'll see some pictures of the day after, because we really weren't out there that night taking pictures. Everything was underwater on the west side, so we didn't even attempt to go look at it. We couldn't get to it. On the east plant, finally I got out there and we already had personnel there. And what we were doing was we had shut it down systematically, but we had no raw water coming in, so we didn't have a way to pump at that time. We did not even go to the Perkiomen because we knew that it went underwater. We got our electricians, our vendors, our contractors, a couple other key players in our business, external and internal, to all come out to that facility. And we were able to switch the power from the Schuylkill station from the west feed to the east feed. So now that station had power. It was lapping at the floor, but it did not get into the building at the Schuylkill. I don't think I have a picture of that, but it was quite impressive to see. So once we got the Schuylkill online, we knew we had raw water. Now we had to start the east plant back up to get back online. Problem was most of all of our SCADA and our process control systems were in the west side. So all of that went underwater. So that meant everything had to be run manually. So it took us a couple hours. Fortunately, we had done a tabletop experiment on cyber attack a month and a half ago or before to run in manual. So it was a great exercise. Ran around, we got everything running in manual and probably were online by 6 o'clock, 7 o'clock at night. I forget the exact time. And we were finally able to start putting water back into the system. We have a couple zones that leave there. We hit the one that needed it the most, and that's where it went. At one pump in, one pump out, lowest flow that facility's probably been at. I think we were anywhere between 4 and 6 million gallons for a facility that can do 60 million gallons together. So very reduced. We then, our process control department showed up. They were reprogramming everything to put it onto the East network. Right after I got everything done in manual, they showed up and put the program in, and it all came up and running, which was great. So in the next hour or two after that, they had automatic control, and a lot of their, they could see what they were doing through their SCADA. It was pretty impressive that in less than 12 hours, we had a full system running at the East plant through SCADA. And just talking about the East plant, over time, we turned another pump on, turned some other stuff on. We're able to increase the facility to closer to the 12, 13 MGD that the facility is capable of doing. That happened over what I'll be talking about, what we did at the West plant. So we were continually adding a little bit more every day to that facility. Now we get to the West plant. After we got done running the East plant, we, well, let's look at some pictures. So what do I do here? Just click. Oh. You do it. I'm good if you do it. All right. So what you see is the whole complex when everything looks pretty. On the left of your screen, you'll see the West plant, 2 clear wells, some basins, a lot of filters, and you see a big settling basin in the middle of the print. Under that is the dam, the Pickering Creek Dam. And to the right, you see one clear well and a facility in a parking lot. That is the Pickering East. The floodwater, everything on the left side of your screen was underwater. And the settling basin is high enough that it did not go into that structure, but it came up to around the back of it. And the Schuylkill intake is to the left of that settling basin, but on pillars, so it was high enough that it was not underwater. Go to the next screen. So next day, I think this is the next day. This was taken by probably a helicopter, I think. That is the dam, coming over the dam and how far up it goes to the street. And if you look to the top left corner, there's a driveway that goes into the facility. That's where we were worried that it was going to come down that driveway and into the facility. A lot of it did, but you'll see later on exactly how it completely inundated the facility in a different way. The basins are probably, 20 foot high on the right side. Everything's about 8 foot underwater in there, 5 to 8 foot of water. So, luckily, as this was happening and we knew we were going underwater, we made some key calls even that night. So a couple shout outs. Our electrical contractor, Vitri, who we use for just about anything, was on site during the West flooding and were helping with us. And then they stayed pretty much throughout the whole time and probably are still there. Hawk, we use Hawk turbidimeters, and our treatment department, Dave decided to give them a call and said, they're in the basement and they're probably going to flood. And once they flood, they're sensitive instrumentation and we need it to go back online. Let me call the vendor and see if he has any laying around, because we're probably going to need 1 or 2, not knowing we were going to need 22. So he made that call and was able to get that actually delivered. They showed up like days after this happened. Amazing. Some construction outfits like Ronka and some other outfits came in, along with all of the aqua personnel. So I won't leave any department out. I won't say any names because there's say. And this wasn't the only facility that we were struggling with. So this hit all of our southeastern plants in some form or fashion. So they were all busy doing their own stuff, L's and distribution. Everybody was out working during this time. I'm just going to talk about Pickering West now. The next page. Screen. So the next day, people are standing on the road, right on the bridge, brave souls, watching the water go over the bridge. And the bridge has been topped, or the road has been topped many times before. This is not an unusual event. This is just more than we've seen. When you look at the side shot there, how high the water was, I mean, that's the level of the reservoir right next to you. So it's just going straight across, a little bit of a drop into the Schuylkill. The Schuylkill is pretty high also at this time. Next page. Finally, we get to go in and see what happened. I got to go over there a little bit earlier. There's some other pictures where you'll see some water in there, but this is after the water finally left. And you'll see a picture coming up of what happened. To the top right of your corner, there is a metal dike wall that goes into an earthen dike wall, and in between it breached. So we were dealing with like 2 points of flooding from down the road. That's not what really took it to the next level. It's when that went out, everything came in, filled up the whole bowl. And that clear well, the first clear well, the smaller clear well, was destroyed in the breach. You see it has some weird irregular oval circle at the bottom right of it. It's buckled right there. It pushed or pulled or however it did it, but it buckled. At this point, knowing we were underwater, everything has to be cleaned out. Everything has to be disinfected and everything has to be put back online. That includes all pumps, motors, anything that cannot handle normally being underwater had to be dried out or replaced. And then everything that would touch drinking water had to be sterilized and then planted for bacteria samples. This is us standing on the dike wall, and you'll see the metal dike wall to your left and the earthen to your right. That was all earth there at one time, while there was still water. This is actually my picture, I believe. I give credit for this one. There's still water in the plant at this time, and it's all draining out. We're waiting for it to go down so we can actually do some recovery. Next picture. Same shot. I'm just over a little further to the right where I can look at our big swimming pool right now. Next page. So this is what actually happened, and I kind of went into it a little bit. We had water coming down the driveway. In the middle picture, you'll see the water coming down the driveway there and filling up our storm drain. And our operator's office sits to the left of that middle picture. This is when we decided, a little later, we decided to evacuate. We couldn't keep up with this, and that we wanted to de-energize so there wouldn't be as much damage, we were hoping, and be able to get out of the way. So we were making calls on that. What you see to the right is what happened. That picture, we already saw it, and to the left is what happens after the water left. But we overwhelmed some storm water. We had water coming up from the river, the creek, and then the lake wall. That's what happened. Now what do you do, right? Now everybody goes home and we forget about this place. Next page. Next screen. So this is afterwards. Line of cars on the left, everybody coming in to help. At this point, we have to clean. So we had to shut a lot of valves to divorce ourselves from the clear well. We had to then assess the clear well. We had to bring in contractors, MBA, Stoltz, a bunch of other people come in, Ronca, get into that clear well and suck all of the dirt that's in there. That dirt layer on top of that clear well was everywhere. And it was about 1 inch to 1.5 inches, maybe 2 inches thick. So that covered the whole property. It was amazing. We were at the bottom of a riverbed. It was so wild to see that much mud. We brought in restoration. They started backing this stuff out. Within the first day, we got a nice dent. We got into it. We started being able to assess every application and then start making lists of what we needed to put back online, or what did we need to buy? What did we need to, what could we dry? What did we need to do? The water actually got over top of our filters. Now, filters are designed for dirty water, so it's like, okay, great. But the point is, the whole room was covered in mud. So all of this had to be cleaned out. Next slide. Oh, yep, you can go back one. Yeah, so when you can go inside some of these rooms, you can see what it looked like. So the guy on the right, Doug, our SCADA department, process control department, who came running to the rescue, went and opened his door up, and he has his hand at about how high the water got in that cabinet. So everything from there down is non-functional anymore. Anything above is probably non-functioning anyway, because it pretty much submerged the whole cabinet. In the middle, the power for the whole complex is on the same floor, and that was all underwater. The control room is in the middle, chairs shot this way, that way, filter consoles completely covered, back filter rooms, the manager's office when you run in the first door. We brought in crews from our facilities, our distribution crews and maintenance crews, and they worked very hard in those conditions to remove a lot of that stuff. And then we brought restoration companies in and just cleaned. We just cleaned for about a day, if not 2 days, to get stuff situated while we were engaging with our vendors and contractors. Again, new turbidimeters, cleaning the clear well. We took all our motors off of any of our pumps that were submerged and sent them out to be baked, which is drying them, making sure everything was shut off power-wise. So when the water did come in, there was no energy on anything. So luckily, nothing arced or did anything like that. So it saved us a huge amount of time. Next slide. Pile of trash in the middle is very easy to see. That's one of the piles of trash of everything that came out of the operator area. You'll see on the bottom right, we've been through this before. I was just born. It wasn't. I was only half a year old in '72, but this facility didn't have a dike wall at that time, and the little arrow you see is how high Agnes got. And I'm telling you, we were right there. That's the water line right at it. So it was just as devastating as Agnes was. We have more equipment at this point, so we had a lot more to deal with. But they had their challenges back then also. See some crews, people working pretty much almost 24 hours. Crews were there pretty much 24 hours until you couldn't do any work at 2 or 3 o'clock in the morning, but we were there for days in a row. It didn't end. As they said, this all started on the 1st. Go to the next slide. And then this is the 10th. So now we're on Friday, 9/10. So 10 days later, and the top right picture is us talking right before we're going to flip the switch and turn a pump on. You see some of the stuff we did along the way. The supervisor or the manager of the plant, Dave Morosi on the bottom right, is turning the pump on right there towards the end of the day on Friday. So in 10 days, we were able to go back online at somewhere between 7 and 10 million. And then we moved to another one, and then we moved to another one. But we were online in 10 days. To the left is a filter, and we're just talking about how we're cleaning it up and getting it ready, disinfecting it so that we're ready to put that online too. So it's part of the process. Next page. Not only did the plant have a lot of work to do, this is out in the system. We have other plants, we all pump into the same system, the main system. Pickering West is one of the main, well, it is the main plant that pumps into the main. Then we have another facility, Crum, Upper Marion, Chamonix, a couple of others that all pump into the same system. How do you move water from a plant that has capacity into a zone that wasn't designed, or you needed to get more water there? Distribution guys figured it out. They put temporary easements, temporary construction, temporary pumps, you name it, to get water moved from one zone to another to support the public. So that's some of their props to that group out there. And here you see just the East plant. The East plant did not go underwater. The East plant is well above the flood zone. The East plant is where we're going to build a little more on in the future. Expand the size of this plant from a 15 MGD. We're hoping to move into 30 MGD. Take a little load off the west so that we now have a full loaded facility that can go off or on. I don't know if anybody has any questions, but I'll try to answer anything you have. Yes, you're first. Oh, okay, yeah, I can do that. Yep. Who? So the question was, can you expand more on what Aqua would probably be doing, because we may be experiencing more flooding in the future? And yes, I can expand on that. We are going to be doing some drainage issues at the West plant. Let's just start with the West plant. We're going to divert, fix some culverts, get some stuff so that the water coming down the road and what was coming into the plant originally, alleviate that. There's a project right now to handle that. We have already repaired the dike wall. It was done probably maybe a couple weeks after the breach. That was what we worked on simultaneously while we were doing our work. We are not planning to raise the dike wall on that facility, just for, you know, raising dike walls and an area around your facility is, you know, trying to get all the permits and everything you need to do that. It may not be beneficial for us. We are no longer going to use the one set of filters that were from the 1910s, 20s, whenever they were, the one where you saw the console on the screen. We are going to expand at the East plant. So we're going to put some flood doors, some flood control on the West plant. If it happens again, which it will not happen again, I can't say that, but I hope to never see it happen again. For just that facility, that's what we're talking about doing, those three things. In Aqua, we do review our 500-year level flood, and we've already have reached out and have looked at the dike walls and the other facilities that we have. That's what we have right now. Any other questions? Yes.
So Jeff, this is Joe Duras online with the USGS, and it's not a question, but I wanted to let you know that some of the work that we're doing right now in response to all that flooding with Ida is, as we had crews out. Well, you guys were cleaning up. It looks like we had crews out marking high water marks in connection with FEMA, and I think we have it's like 12 or 14 sites where we're going to do what we call an indirect discharge measurement. So basically using those high water marks to compute what the discharges were at that kind of gauge height that was in some cases above a lot of our gauges. So and part of the reason that that's important is because that can redefine the 100-year and the 500-year flow statistics. So that'll come out in a report probably in the next like 6 months or so. So I just wanted you to be aware that those numbers, that 100-year and that 500-year could probably be, they will be affected by IDA. So yeah. So just a comment, but that's pretty spectacular.
And it's a good comment. Perkiomen was rebuilt. Our Perkiomen intake was rebuilt for the 500-year flood.
Okay.
And it went over it. So we are going to have to, you know, rethink the Perkiomen facility. So those maps will be invaluable, and we'll make investments as needed when they come out and overlay them over top of our territory to see what we need to do.
Great.
Prevent or live through the next one. Thank you.
Yeah. Well, it's pretty amazing. So thanks for sharing that.
The question was, how did we recover from the computer electronics digital systems? Well, as you saw in that pile, you didn't just see piles of drywall, you saw computers and other things. Not really, but everything was removed and taken back, and they were pretty much trashed. The IT components of the facility are all backed up, not on site. So not an issue from that on the IT side. The SCADA side, the process control, we're at the plant. We were able to, we have some of it, but there were some pieces that were lost, data that were lost. But the programming was all backed up on another server. That's how our process control department were able to come in less than 12 hours or almost 12 hours later and rewrite and pull programs over and put us back online that quickly. My process control department's always told me, go down, Jeff. Less than 24 hours, we'll have the SCADA back on. And I said, I'll hold you to that. Never thought I had to, and he did. So in less than 24 hours, I had on automation and stuff like that. We had to buy a lot. There was a lot that was lost. We had to replace a lot of our flow meters. A lot of the electronics on that had to be replaced, but the meter was fine. You just had to replace the electronics, and some of the probes had to be replaced. All, I will say, one really neat, all of our valves are actuated. The company's back. The guy always told me, while they're not rated to be, sitting underwater for X amount of time, they're sealed. Yeah, okay, we don't ever want to test that. We did. And then our electronics group or our electricians came in and pulled the heads off each one of them, and they were dry inside. So all of our valving automation for the valves were all, I think we lost one out of 5 to 6 per filter and 22 filters. We lost one. Very good. Yeah. So the first one was, I'm going to go backwards, safety concerns. Did I have any safety concerns? Yes, we had a lot of safety concerns. I had well over 50 people on site in an area that only has 2 or 3 people usually walking around during the day. So we had safety talks every morning. We had safety there every day. They were walking around, say our internal safety. We had our external stop by. The safety talks were huge, and you saw the one safety talk before we went to start, because we're all trying to do our own little piece, and we're all in our own area and trying to keep everybody together. My boss was there every day, and he was kind of trying to keep tabs on everybody to make sure we knew where we were, along with a couple engineers, or at least another engineer friend was there, trying to get the communication, because we were all trying to move as fast as we could, and you can't. You have to do it systematically. You have to do things in a certain order. You can't do it you try to do something before you do something else, and you just be back again and cleaning all over again, because you're dealing with, clean water, trying to clean the water along with safety at the same time. So, safety talks and the communication were important. As far as the structure has been there for a while, there were no structural safety concerns. The buildings were wet and slippery, and yes, you had to watch your footing when you were walking around. Other than that, we did not energize anything until we cleaned, and then it was done by the electrical contractor with nobody in the area, and to keep tabs on what was electrified and what wasn't. It was put on and then turned off, and put on, tested, and then the final day, everything was looked at piece by piece to make sure that we were where we needed to be to start, but not just leave power running by itself, with nobody around. Did I answer that one? What was the other two? Where are we now? Where are we now is a middle question. Where are we now is a facility that I believe Aqua is fortunate in having is a lot of redundancy at their facilities. So that facility has 7 send-out pumps. 4 of them are online right now. The capacity of that facility is around 25 million right now. We're pumping that. It's a little less than what we would have been pumping on our highest day in the summer, and that's why we want to upgrade our East plant to recoup some of that flow. But we're fully operational right now. Fully operational, and meeting demand with everything that you saw in the system that we were doing is offline now. That's where we are now. We have projects planned this year that we will be doing a new clear well over on the East plant. We have a pilot going on at the East plant for filtration rate, and we have investigating the raw sources to easily get the raw sources to the East plant. And the first question, what was the first one? Yes, good. So what can other plants or what can other facilities learn from this? Really, I will say this, we did do a tabletop prior, and I was amazed in the tabletop who actually spoke up when we walked around. What would you do if the plant had to run a manual? And I actually needed that knowledge the day of this, leaning on the plant staff to help with what needed to be done, how the plant operates was very important. And then communication was important, but redundancy. And you really need strong relationships with your vendors. We do have strong relationships with our vendors. That is very important. A lot of vendors.
Thank you again, Jeff. That was a really powerful story. I think our entire room here was transfixed, probably the same on the Zoom. It was like you could, drop a pin in here. Yeah, definitely a compelling story. Last, but certainly not least, we're thrilled to have Kelly Anderson joining us today from the Philadelphia Water Department, joining us virtually. Kelly is the program manager of the Water Resources Planning and Protection Programs Department at Philadelphia Water Department, oversees climate change adaptation, water quality compliance, modeling source water protection, and watershed field services. She joined PWD in 2005 after graduating from Drexel with Bachelor of Science in Environmental Science, and is currently a program fellow at Duke University's Water Innovation and Leadership Development Program. And she has the task of pulling all this together and giving our send-off for today. So thank you so much for joining us, Kelly.
Thank you. Can you hear me, Megan? And can you see my slides?
We can see your slides and we can hear you.
Awesome. That's a really tough act to follow. I feel like in a way, reflecting on Jeff's presentation, the benefit of having these types of forums is that, we as water suppliers and regulators and folks that have our eyes, ears, and brains on this water supply 24/7, it's just nice to know and have these types of forums to share and, empathize with each other. So, I'll get into it in a couple slides, but we also had challenges from Ida, but we definitely had our eyes and our thoughts with Aqua during, that situation. We were dealing with our own challenges downstream, but part of the benefit of the Schuylkill Action Network and having these types of forums is to share and exchange information and hear, how our brothers and sisters in the water supplier community are dealing with, the challenges of today and going into the challenges of tomorrow, which are now the challenges of today with climate change. So with that, good afternoon and happy Friday. Happy to be here today to discuss Philadelphia's One Water approach to water resource management. The term One Water describes a comprehensive and long-term approach to community-based water management. A One Water approach recognizes all urban water suppliers as resources, looking at surface water, stormwater, and wastewater and their impacts and how we manage those impacts on the water environment. These interconnected resources are managed for the combined impacts on flooding, water quality, and river health. And this comprehensive management of all water supplies considers multiple end users, improves the overall quality of life in a community by benefiting both the environment and the economy. I feel like the phrase One Water is a newish phrase that describes what many of us have been working towards for years with watershed protection programs, recognizing that interconnectedness of water management practices and applying those management strategies to improve upstream and downstream conditions and communities. Just a little bit about PWD. The primary mission of PWD is to plan for, operate, and maintain both the infrastructure and the organization necessary to provide high quality drinking water, to provide an adequate and reliable water supply for all household, commercial, and community needs, and to sustain and enhance the region's watersheds and quality of life by managing wastewater and stormwater effectively. PWD is responsible for supplying drinking water and managing a watershed that supplies drinking water to 1.6 million people within the city. We also collect and treat wastewater. We have about 2.2 million wastewater customers. We are responsible for managing wastewater from some of the outside communities of the city. And same with stormwater, storage and management of stormwater, and making sure that when stormwater rain is hitting the ground, that it's being managed through nature-based solutions, and then within our collection system and at our treatment plants. In fulfilling our mission, we seek to be customer-focused, delivering services in a fair, equitable, and cost-effective manner with a commitment to public involvement. Having already served the city and region for nearly 2 centuries, the utility's vision for the future includes an active role in economic development of the greater Philadelphia area and a legacy of environmental stewardship. And this, our core functions are really centered around both the Schuylkill and the Delaware rivers. We have 2 drinking water intakes on the Schuylkill watershed and 1 drinking water intake on the Delaware, and our 3 wastewater treatment plants are also located along the Delaware River. There are 5 major components to the planning approach taken amongst PWD's water resource planning programs. I'm going to touch on these 5 components throughout the presentation today. First, we really need to understand conditions, and this includes researching and assessing the specific water resource management challenges that we're encountering, within the city and outside of the city in our watershed. This includes taking a deep dive into the science, research, and literature, and understanding what technologies are necessary to best inform, our planning considerations. We also start to think about what additional PWD planning efforts would be informed by understanding the issue more. An example here is, thinking about emerging contaminants. We heard a couple of presentations earlier today about PFAS. This is a very hot topic at PWD, and, as a utility that's responsible for managing wastewater, stormwater, and drinking water, my specialty is in the source water, drinking water side of things, but now we've had to shift and apply the knowledge that we're learning from our source water and drinking water side to our wastewater and biosolids management side. So really sharing information and with all sides water and how, emerging contaminants impact all sides water. Next is analyzing. This includes conducting monitoring and modeling efforts to evaluate our and assess our watersheds and our systems. And the analysis part is really the backbone of how we plan. PWD has invested a lot of resources into our modeling efforts and our monitoring efforts. I'll get into some of those in some of the preceding slides. But we really see, having sound science and having the best science available is, critical at making decisions and informing stakeholders in the community and within the region on how PWD is, approaching managing drinking water and wastewater services for such a large customer base. Finally, moving into planning, we develop planning approaches that share and communicate results with our asset managers at PWD. Also externally, we make an effort to share information with regulatory agencies along with watershed partners and stakeholders and other water suppliers. Partnering is absolutely critical as a testament to today's presentations and being able to participate today and seeing how far the Schuylkill Action Network has come over the past 20 years. It's so important to be able to have mechanisms like watershed collaborations and partnerships centered around shared water resource challenges to share information, data, science, and ultimately to inform decision-making and planning at a broader scale, which is needed when you're looking at a watershed the size of the Schuylkill, which is 2,000 square miles, within the Delaware watershed, which is almost 13,000 square miles. Philadelphia has about less than 2% of that area within our jurisdiction. So for us to be best, informed and best managing our water supply, we really do need to partner with folks and other water suppliers upstream. And then finally, implementing work. By working with partnerships, we're able to implement projects to maintain and improve the health of our watershed and ultimately, protect the water that we're delivering to our customers. Excuse me. As the old saying goes, you can't maintain what you can't measure. Understanding the region and having planning efforts in place grounded in science and supported by modeling and monitoring has been the backbone, as I mentioned, to PWD's understanding of our waterways and our watershed. Data collection monitoring programs have been essential for us to, assess our source water, assess our receiving waters, And then some of the images here are PFAS sampling being collected at our intake. It was great to hear from the presentations earlier from Joe at USGS and the biosolids presentation, and then, hearing about EPA method 1633. These are all things that we at PWD are thinking about, all sides water. The slide on the image on the lower left is showing a bathymetric survey that was done along the Pennypack Creek, looking at different conditions and as they relate to, watershed health. And then we have buoys. We have many buoys deployed in the estuary that are collecting data such as salinity, tidal currents, and wind that help feed into our models and our analysis that's ongoing, both looking at, drinking water and wastewater impacts. Moving along to source water protection, the foundation of the SAN. Understanding and analyzing our watershed conditions was spearheaded by a PWD source water protection program in the early 2000s after the 1996 amendments to the Safe Drinking Water Act, which required water systems to assess their source water, identifying actual and potential threats to their water supplies. It was really nice. I have to give a nod to my old boss, Chris Crockett, who I saw in the beginning of this presentation. He created PWD source water program back in the early 2000s, and I was fortunate enough to start working under our source water program in 2002. So PWD, we made that decision at that time to invest in cryptosporidium research, given the Safe Drinking Water amendments towards LT2 after the cryptosporidium crisis in Milwaukee. Our source water assessments led to the creation of our source water protection plans, which were aimed to address the challenges, identify priority sources of impairment and risks, and also then, ultimately lead to implementation plans. So, we've been proactively sampling and collecting crypto data since the early 2000s. And this also gave us an advanced indication of, our LT2 priority focus in the watershed. With less than 2% of the Schuylkill River watershed within Philadelphia's jurisdiction, a regional coordination approach was needed to meet source water protection objectives. Our protection plan identified the need for a partnership approach to tackle these upstream issues. By sharing PWD's water monitoring and laboratory expertise and resources, we were able to collect and share watershed data, which ultimately brought more folks to the table. So how does Philly have relationships with the farmers and other folks upstream that are necessary to have at the table? We have really, appreciated and been so grateful to, have been a founding member, but also to continue to be at the table with the Schuylkill Action Network, which is a watershed scale stakeholder coordination. I'm assuming most people in the room are familiar with the SAN because that's who's organizing today's event. But for those that aren't as familiar, the Schuylkill Action Network was established in 2003. There was an EPA targeted watershed initiative grant that was awarded to the Partnership for the Delaware Estuary and PWD to the tune of about $1.15 million at that time. And that money was able to be leveraged by multiple other sources to create, sampling programs, monitoring programs, assessment programs, and then ultimately implementation projects to create BMPs and other nature-based solutions and, structural solutions to mitigate pollution from entering into the watershed. The SAN encompasses both all water suppliers from the watershed, the regulatory agencies, conservation districts, nonprofits, other stakeholders. And then the targets of the SAN include abandoned mine drainage. So thinking back to this slide I showed before, sorry, I didn't acclimate folks, but to the left here, I figured most people are familiar with this Schuylkill Action Network. We, when we did our assessments, we identified abandoned mine drainage, agriculture runoff, and urban stormwater pollution as the major drivers towards the impairments within the Schuylkill watershed. So the SAN, developed work groups around these specific issues, which are still actively and very, even during the pandemic, I believe more people are actually coming, to the table because you don't have to drive all the way from Philly to Pottsville. But, we always enjoyed driving to Pottsville. It was actually really wonderful to see, some of these issues firsthand. But looking at and addressing abandoned mine drainage, agriculture, always keeping education and outreach at the forefront, the pathogens and point sources work group, the land collaborative, and then thinking about stormwater and recreation. So moving along, there were a couple of presentations earlier today, which were awesome about PFAS. We're, very much involved with emerging contaminants monitoring and understanding, analyzing, and thinking about how PFAS is impacting our watershed, and thinking about the regulatory environment and how new and ongoing regulatory developments will impact our planning programs. We look at both safe drinking water and the water supply planning priorities that create the need for enhanced communication and robust partnerships aimed to tackle watershed scale issues and future regulatory planning considerations related to emerging contaminants. By working in partnership with other water suppliers such as Aqua and American Water, which we have been communicating with, and it's been great to be at the table with them and share, what we're seeing when we're doing our monitoring and what they're seeing when they're doing their monitoring. We're really able to have a more complete understanding of the complex challenges confronting water suppliers and create coordinated monitoring and data sharing programs, along with just really, having empathy and having the ability to work together has been instrumental at really understanding the issue. And we couldn't have done that without, organizations such as the SAND. And of course, working in tandem with the regulatory agencies helps keep the regulators aware of the complexities of some of these issues as they work to establish new compliance standards. Similarly, we've been proactive in our communications surrounding PFAS and our sampling programs for PFAS that PWD has been undertaking since 2019. All of our data has been compiled, analyzed, summarized, and made publicly available on our website, which we will continue to do. We believe that by having this information publicly available and vetted, we ultimately save ourselves time on the back end when media and other inquiries are presented to us. It's very, very, very important for PWD to be transparent with, what we're doing, how we're doing it, why we're doing it, and what results we're seeing. And on the other side to this, we've also been able to use our PFAS website to respond to erroneous reports, such as those by, there was a report a couple of years ago by the Environmental Working Group, which we took issue with, and we were able to use our website and our PFAS communications on that website to respond and react to that. We've also recognized that source water protection regulatory drivers, with the example here being LT2, can also act as a tool to accomplish multiple watershed improvement goals. Through genotyping research, we determined that animal vectors like geese and cows, along with wastewater effluent, can be contributors to elevated crypto levels in our watershed. By addressing upstream agriculture runoff through various BMPs, like manure storage basins or better stormwater controls on farms, we are receiving compliance credits for our watershed control plan, which is an LT2 requirement. And we're also addressing nutrient and sediment issues, which is fascinating and compelling as we work to meet ongoing and future MS4 requirements within the city. These types of one water BMPs allow for source water improvements for downstream drinking water utilities, along with stormwater and habitat improvements at the local level and at the farm. So really, it's an improvement to Philadelphia. It's an improvement to these farms that are located upstream and the farmers that are working on these farms upstream and the communities in these farms upstream. So we really see, these types of projects benefiting not just, us from a regulatory perspective, but also really improving the environment, improving the watershed health. We've been able to use our LT2 watershed control programs to help justify and bolster goose management programs throughout Philadelphia's park system, which leads to improving public health conditions beyond just the fence line of our facilities. I mentioned, or I'll mention that the Schuylkill Restoration Fund is a public-private partnership that was established in 2006 after the targeted watershed implementation grant from EPA. This has been a shot in the arm that we've been continuing to invest in, and have continued investment from other folks to work towards providing grants to communities, municipalities, nonprofits, farmers, landowners to improve watershed health. Since 2006, we've awarded over $4.6 million towards 120 projects, leveraging $9 million in additional funds. Grants are typically directed towards agriculture runoff, abandoned mine drainage, and urban stormwater issues. And it's been, the Schuylkill River Restoration Fund has been an opportunity to combine resources to accomplish multiple watershed protection goals. So while PWDs focused on pathogens, sediment, and nutrients, other communities who also have those same interests are able to work together to combine funding and different resources to protect a watershed. So it really does take, and this is a watershed approach at optimizing watershed investments. And I would be remiss if I didn't say that thanks to the leadership of the Schuylkill River Greenways, and then the contributors, Aqua, Exelon, PDE, and Mom's Organic Market, and I think recently Pennsylvania American has started to contribute to the Restoration Fund, which is awesome. These public-private partnerships really are incredible examples of what it takes to manage a resource like the Schuylkill. Just real quick, walking through some examples of projects that have been, accomplished through the Schuylkill River Restoration Fund. This is the Grube Farm, which is a dairy operation in Berks County. And we partnered with, or worked through the Schuylkill River Restoration Fund to award funding to complete some liquid manure storage basin installations on this property. There were also other BMPs that were accomplished at this location. So, these types of projects are estimated to capture approximately 7,000 tons of nitrogen, 1,000 pounds of phosphorus, and 250 tons of sediment. And the reason I call that out is because while we're looking at these projects from a drinking water protection, Safe Drinking Water Act, perspective, these are also the types of things that Pennsylvania DEP is requiring folks to be measuring, monitoring, and protecting as it relates to nutrients and sediment. So this is the Grube Farm. It's a dairy operation located up in Berks County, as I mentioned. In 2019, the Grube Farm was awarded a USDA NRCS Environmental Quality Incentive Program, or EQIP contract, to implement ag conservation practices on their farm. And it's important to note here that EQIP funds go a long way, but they only cover 50 to 75% of the project cost, and other funding is needed to supplement the project and assist with considerable operator out-of-pocket costs. So before receiving a Schuylkill River Restoration Fund award, there was no manure storage on this farm, allowing nutrient, sediment, and pathogens to run off into an unnamed tributary to the Irish Creek, which eventually drains into the Schuylkill River, which is our water supply. The suite of agricultural BMPs are estimated to capture approximately 7,000 tons of nitrogen, thousands of pounds of phosphorus, and tons of sediment. So the Restoration Fund was able to help give that extra support to the landowner to match the funding from USDA to complete this project. So you can see some pretty compelling before and after photos here with both pre-construction and post-construction. Closer to Philadelphia, we are focused on looking at the areas both outside the city and inside the city. And although there are not as many ag and animal use areas within the city, we identified Northwest Stables, which is along the Wissahickon Creek, as an area that needed a little bit more attention to manage runoff, stormwater, sediment, nutrients, and pathogens. So a restoration fund grant was awarded to improve the drainage along these sites and reduce pollution runoff to the Wissahickon Creek. And just some photos before and after here showing all the manure, different sediment knocked up. And then we were able to stabilize approximately 41,000 square feet of paddocks with earthen material. We installed some trenches and drains. There was actually a nice event last fall to give a tour of this location, but you can see the dramatic improvement of both before and after. And then, you know, thinking about climate change and the impacts that we're experiencing from already more intense cloudburst type storms and situations that come with more increased hurricanes. This was the Northwest Stables after project implementation, but showing how this project was able to alleviate and remediate and mitigate stormwater. You can see here that during the August 4th post-Hurricane Isaias, the paddocks were flooded. And then thanks to the drainage and additional BMPs that were installed, stormwater management BMPs that were installed at that farm, the stables were able to be used and drained and managed the next day. I would be remiss if I didn't include information on our climate change adaptation program and planning approaches to make climate science actionable for PWD infrastructure planning. Tying back into Jeff's presentation earlier, these are some photos of the impacts we experienced in Philly as a result of Tropical Storm Ida. Much like Aqua and those impacts along the Pickering Creek, PWD and the city of Philadelphia saw the immense impact of flooding stemming from this historic storm. So these photos here are the tidal Schuylkill River on the left from Center City. The upper right photo is the Manayunk neighborhood in Philadelphia, which is located just above two of our drinking water intakes. And then probably one of the more dramatic photos from the city of this time is the Vine Street Expressway 676, which experienced a lot of flooding as well. We formalized our climate change adaptation program in 2014, recognizing the need to connect PWD's water resource planning programs to PWD's infrastructure and capital planning efforts, taking a deeper dive into the climate science while performing vulnerability surveys and risk assessments to create a comprehensive set of design guidelines and recommendations for PWD's facilities, along with our linear asset planning programs. The science is in consensus that Philadelphia will experience an increase in precipitation and extreme storms. We're also expected to see sea levels continue to rise. Along with that comes with changing water quality conditions in our watershed, along with increasing air temperatures. We have developed, I should say, design guidelines that are intended to provide new IDF curves and DFE inundation levels for both our wastewater and drinking water plants to incorporate into major capital infrastructure improvement projects that are going on now. So it's exciting, you know, post Ida, which was traumatic and dramatic, and we experienced a lot of challenges at our Schuylkill intakes. But you know, taking high water marks, working with our water facilities planning team, we've been able to create new design flood elevations, which will be used in the creation of new pump stations that are being planned at both of our drinking water facilities along the Schuylkill. Our program's current priority is to mainstream climate information into the planning, design, and operation practices at PWD. We think about this in terms of how our existing assets can be adapted to climate change impacts and how new assets can be planned and designed to ensure long-term resilience. There are 4 areas we're focusing on to begin mainstreaming climate information and increasing PWD's resilience to a changing climate. And these include performing risk assessments to identify strategies and investments needed to protect our assets, implementing climate change planning and design guidelines for PWD, informing long-term infrastructure plans, and finally integrating this climate science and information into PWD's capital planning process. And I'm happy to say that we were able to have a policy formalized earlier this year, at the beginning of this year, requiring that all PWD planning and infrastructure planning has to take into consideration the information that our climate change adaptation program has developed as new assets and new infrastructure is being added and updated to the city. So finally, how do we measure success? Just a couple notes, and I know I'm keeping you between this presentation and lunch. We really, we do look at aquatic health improvement. So we are looking and monitoring, measuring the return of shad and sturgeon to the Delaware and Schuylkill rivers. We also have seen an increase in the number of fish crossing the fish ladder into the Schuylkill, and those are, testaments to the improvements that have happened in the watershed. PWD continues to invest in our CSO compliance programs. We have a large-scale green infrastructure program, which is targeted to manage the volume of stormwater, which will impact the amount of sewage overflows that are going into the streams. The local economy, we're funding and leveraging money for environmental restoration projects through the Restoration Fund, which I mentioned earlier. Regional partnerships are critical. The Schuylkill Action Network is a proven interagency and stakeholder coordination model, and we're looking to expand that and, hopefully replicate this model in the Delaware watershed as well, specifically in the Philadelphia or within the Southeast Pennsylvania area. We want to mimic what we've created in Schuylkill in the lower Delaware to, as a similar driver to meet LT2 compliance. And, regional partnerships create a stronger commitment to data science and sharing information with our partners. As the most downstream water utility in the Schuylkill and Delaware River watersheds, it's clear to us at PWD that we truly are all part of a one shared water. As has been demonstrated by the incredible work achieved through collaborations like the SAN and the Restoration Fund over the past decade plus, understanding the one water concept and incorporating it into the analysis and our planning approaches allows us to work with partners throughout our watersheds to implement projects and initiatives that create real water quality benefits and a healthier watershed for all. I felt like I plowed through that. I know that you guys are probably all rushing out the door to get your box lunches, but if there's any questions, I'd be happy to take them. Or if folks want to share my information in the email, in the chat, my email, I'd be happy to follow up with people afterwards.
Thank you so much, Kelly. We do have a question in the room from Glenn. Glenn, I can just repeat your question if you'd like. Okay.
So Kelly, I'm Glenn Evers, and I've worked with PFAS for many, many years. It sounds like to me you've got you see the red light that's coming in here on PFAS and what it means. Earlier today, we had a presenter talking about brine, and certainly one of the secret ingredients in fracking and in oil recovery are fluorosurfactants, because they're very high temperature resistant and they're very good at working down to help recover and penetrate into the soil. That water then comes up through the surface, and because these are proprietary ingredients, you don't know whether or not your brine solution, which is being spread out all over the roads, has PFAS in it. Then there's surfactants that are used for painting buildings in the city of Philadelphia that also have PFAS. Then you have the carpet cleaner guys who come in and give you the upsell and put the additional fluorochemical on the carpet, which is not entirely substantive to the carpet because it may already have fluorochemical in it. And then in addition to that, you have biosolids, which pick that up. And we just recently see in the reports that in Michigan, there is a farmer who actually used biosolids with PFAS, produced grain, and then fed his cows, and then had to pull his meat back. His soil is completely ruined. So my question goes back to this issue of PFAS. Is PWA doing anything to put the halts on the input of PFAS into your water system? Are there any regulations that are coming in that says, look, garbage in means garbage out for a lot of people?
Great question. PWD's focus has been on monitoring, analyzing, and understanding the sources and non-point sources of PFAS. All your examples, point to how complex this issue is. People, humans, the clothing we wear, the food packaging we consume, the products that we have in our home, the cars that we drive, are all out of the control of our water, of a water supplier. So it really does take a One Water partnership approach to educate, share information, and to develop a strategy that makes sense at addressing and mitigating these issues that don't fall squarely on the shoulders of the water supplier. It's going to take widespread legislation. It's going to take increased rules to how waste and, how products are being developed, how products overseas are being imported. And that to me is bigger than what a water supplier can address. But what we can do is collect information, share that, communicate that through partnerships, through our relationships with the regulatory agencies, through lobbying, through working with the state, through communicating to the federal government and the agencies that are, responsible for managing this, that it should not be on Philadelphia's ratepayers, which are, one in three ratepayer in Philadelphia is below the poverty line. We shouldn't be responsible for having to clean up the waste of, legacy impacts and then the impacts that are coming into our communities now, because clothing, carpets, tires, food packaging, it's a complex issue, and it's going to take a complex solution, but it's definitely something that we're thinking about, Glenn, and it's something that I think is going to take a lot of thought and a lot of brains in the room and folks like yourself and forums like this to raise this issue and show that it's more than just, it's more than just throwing a regulation at a water supplier. It's going to have to take a multifaceted approach to manage all the sources.
Really well said. Thank you, Kelly. I am not seeing any other questions in the room. I think we did have one virtually, a raised hand that we saw from Leslie, if she's still with us. Hold on, bear with us, Kelly.
No worries.
Thank you. And that may be sorry. Okay, her hand went down. So I think that was a great, really comprehensive overview of all of your programs. Kelly, thank you so much for joining us today and kind of closing us out around the theme of One Water and all the connectedness. Thank you so much. Some quick final reminders to you all. Please fill out our feedback survey. We also have some funding resources that we compiled for you as well. This Zoom should close out and feed directly into that feedback survey for you virtual folks. And as you are headed out the door today, for those of you in person, we'd appreciate if you can return your name tag and your survey at the same time. Thank you all again for joining today. And we invite any last minute questions, but I think everybody's kind of in that mode to move on to the next thing. Thank you all so much.